Absolutely. tools. I didn't intend to leave that last line in there. That was a note for me. I was going to think about it and decide. I'm not 100% sure about the future of this tool. My Oracle and whatnot is generally trying to consolidate and make things a little bit more consistent. As such, there's a different flavor of this that is probably more likely to persist. No, I would imagine it's multiple threads reading and multiple threads writing to basically you've got a thread, it reads, turns around, writes. So there's multiples of those. Just depends on where you set it to. Default is 2. So obviously much better if it's a and again, this one scales with those, and this one comes to a single file, whereas this one basically does the same thing. It comes to multiple files. My one version one I would probably be more inclined to use if I was doing a logical dump and I want things like including variables. This is an open source tool. It's not built into your client packages for MySQL. But again, it's open source, so it's easy to find, grab a package for it. And again, this is a multi-threaded logical backup, just like the previous one. But again, the big difference is it's multiple files, and it's file per table. And of course, it supports consistent backups with different storage engines because, that's the whole point. When backing up non-transactional, such as my see people using this. But really, it's because most of my clients are fully open source. So this works by copying the data files. And while it's doing so, it's copying the stream of changes out of the redo logs. So it's basically pulling things as fast as it could possibly do so. And of course, streaming them somewhere else. Once all the InnoDB tables are copied, it issues a lock for the non-transactional tables. This is awesome because it means you're minimizing the global lock for, like, for example, your MyISAM tables. So it does all the transactional tables like InnoDB, grabs them, and then global lock real quick grabs the MyISAM tables and releases that, and it's done. That's that short lock to there's a short full lock to grab that to make everything is consistent, and of course it releases all its locks. This is actually my go-to for physical backups, is extra backup.
It's an open source tool developed by Percona. It's been out forever now. But this is the go-to, at least mine, and obviously pretty much most of my clients. It basically works pretty much the way MySQL Enterprise Backup works. No license is required in this case. It's free open source software. It follows the MySQL release cycles, but obviously Oracle doesn't share their source code ahead of time. Go figure. So, obviously they need time to test and develop the features. If MySQL releases a version of the database that has a backwards incompatible change. So definitely before upgrading your MySQL to like the absolute latest and greatest point release, make sure your extra backup, if you're using it, works. Because otherwise you could be running the new shiny and not have backups all of a sudden. So MySQL 5.6 is deprecated. I hope not too many people hopefully are using this anymore, although I still see a lot of people using it in my business. But it's deprecated, right? No more security changes, no more bug fixes. Please get off of it. And if possible, jump straight to 8. 8's been out now for, God, what is it, 2018? I don't remember. Long time, 2018. That's a long time, 4 years. Please, get your testing done and move to 8. Like, I see people going from 5.6 to 5.7. You're killing me here. So anyway, with 5.6, if you still have it, you're using extra backup 2.3. If you're using 5.7, you're using extra backup 2.4. So MySQL 8 is where you want to be careful. Oracle just a couple days ago released 8.0.30. The 8.0.29, double check my numbers, never trust anybody. Double check my numbers, but 8.0.29 extra backup just was compatible with 8.0.29, which I think was what, like a week or two ago, something like that. But anyway, the point is just be careful. Make sure your extra backup works for the version of MySQL that you're using or planning to use. And the turnaround time seems to be pretty quick for Percona on the extra backup. Again, it just depends, was there a backwards compatible breaking change or not, and how complicated it is to fix that, to add that compatibility. Snapshots are awesome. If you're not using them and you have the capability of doing them, you need to look into it. So there's a lot of different ways you could be doing snapshots depending. Yes, sir.
Sorry, going back to the previous slide.
Yes, sir.
Does the extra backup one-way parallel options?
I'm not sure if it's parallel or not. I'm getting nods, yes, in the background. Thank you, sir. I'm getting a couple nods, including a colleague of mine. So yes. Yes, parallel. Yes, sir. Disk snapshots are awesome. There's a couple different ways this can happen. For example, if you're running Linux and maybe your volumes are set up with LVM, you can do LVM snapshots. If you've got VMware, you can do snapshots. Google has snapshots, Amazon, Microsoft. Your SAN, if you're using it, which is painful for a database, but it just depends on your infrastructure and your needs. Your SAN probably has backups, and of course there's others that I'm not covering. I think NetWare has them, like there's a lot of different options. But if you can do snapshots, they're awesome. Many of the modern storage solutions and cloud providers have them. And it's basically a really, really fast copy of your database, like minutes to do hundreds of gigabytes. Terabytes are very quick, maybe just a couple of minutes to do like a terabyte of data. If you're running the extra backup or, God forbid, one of the logical backup tools on a terabyte of data, it's going to take, so a logical backup on terabytes of data, you're probably talking, what, like a week or something? I mean, obviously, depending upon the speed of your storage, your network, all the different things. And by the way, in case I forget to mention it elsewhere, because I don't remember if I have it in my slides, when you're doing backups, again, don't have them on the same server. So one nice way of doing the backups, typically you're going to do it on the server instead of remote. It just depends. But I usually like to do my backups originating on the database server, meaning I'm running the command there and then streaming them elsewhere. But the streaming it elsewhere could be just as simple as, okay, I've got a SAN or whatever, or a GCP disk, whatever, that I've attached to this server and mounted that volume. So now you've got a new drive, new folder, a new volume representing a data storage device that's attached to your server. So you could literally be, your backup could literally be saying, okay, just shoot it to this directory on the same server. It's not actually on the same server, so it solves your problem if the server goes down that you've got a copy somewhere else. And that makes it really easy. You can just detach that volume or whatever when you're done, whatever your needs are. So when you're doing these snapshots, you need to do a little bit of work because you want to make sure you're completely consistent and everything's flushed to the disk, that kind of thing. So you'll want to do something called like a flush tables with read lock, where you stop all new writes coming into the database. Depending how busy your database is, this could take a minute. It also depends how you implement this. A little bit later, I'll talk about how you implement it and how it might impact the flush tables with read lock to make it easier. So you grab that lock, that full lock that prevents any writes to the database. You can still have reads. While this is active, you want to grab your coordinates, your show master status, show slave status. If you're running MySQL 8, you can say show source status, source, right? Show source status and show replica status. Obviously, that change has not made it back to the older versions of the database because they're older versions. So anyway, but the important point is you're grabbing your point in time, your current consistency, where you're at right now on as far as the master and the replica are concerned. And then go the extra mile and freeze the file system, because MySQL and or the OS might still be like, oh, well, I've got this data in a cache somewhere. There's not a lot going on right now. Let me flush it to disk. No, that's bad. So freeze the file system. Make sure absolutely nothing else is happening. Now you can grab the snapshot and you're sure that there's nothing else going on. Obviously, at that point, you want to unroll it in the opposite order, unfreeze the file system, verify it, unlock the tables, verify it, make sure everything's good to go. And again, even with terabytes of database, this is super fast. Yes?
Since you are mentioning source replica, would you take this from the source or target?
I'll talk about that later, but you're going to grab it. You're ideally going to grab it from the replica. But yeah, we'll be talking about backups from the replicas in detail. There's obviously a ton of other tools. There's too many to go into. A lot of times but the point here is that a lot of times under the covers, they're basically just using one of the other tools. Like for example, the Holland backup tool is using MySQL dump or extra backup. Even some of the commercial tools such as Commvault includes support for all the physical backup tools. And again, there's a lot of different options. But for me, what I see most of the time, my solutions that I recommend to clients, snapshots if you've got them, and maybe a logical dump at the same time. Not at the exact same time, but do logical backups maybe once a day or something, or once a week, and then do the physical backups probably more often, again, just depending, so that you've got the flexibility of both, because you could have a bug that, like I said, maybe somebody wiped out one or two rows or just one table, And if you've got that logical backup already done, and it includes the data you needed, you're golden. You've already got it. You don't have the extra time of having to restore a backup and then pluck out that particular data that you need. Best practices. How am I doing on time? I'm doing pretty good. These are just some things I've seen or experienced. Obviously, feel free to disagree. I'm always up for a discussion. I say it's mostly common sense, but of course, there's so many things that are common sense once you hear it. So I'm hoping, if you don't already know it, I'm hoping you'll hear it here. And if I don't cover it, I've got a good friend in the back of the room that's giving a talk on backups also this afternoon. His name is Pep, so you could always go heckle him this afternoon. But like I said, it's mostly a lot of common sense. So back up your binary logs. Doing so, like I said, you've got that full backup whenever. And then if you've got your binary logs also being backed up, you're going to significantly lower your recovery point objective. Stream it to another server, obviously, just like the backups. You want it somewhere else. So stream it to another server or network file system, mounted volume, whatever, from another device. Bin logs were a thing a while ago, but and you could certainly still use it. A bin log server is basically another type of replica, but it's a replica that's not normal. It doesn't get used for the type of things a replica would normally get used for. You can't read from it and use it to run reports on or queries against. Should I make a joke, Dave, about you yawning in my class? I'm sorry. So the bin log servers are one way to stream the bin logs. I'm sorry, Dave. I didn't mean to call you out there. I thought it was funnier than it was in real life. You can use the MySQL bin log tool again to do that. When I'm setting up a server, in an ideal world, I'm going to have the data on one volume and the bin logs on another. There's a lot of advantages to that, keeping things separated. This way, for example, your logs might not fill your data volume, that kind of thing. Sometimes things happen and you might get slammed with traffic all of a sudden for whatever reason, and all of a sudden your log files are starting to go nuts and you might be filling things up. Maybe you forgot to set the rollover properly, and where it starts getting rid of the older ones. You don't want to just keep an infinite number of logs or bin logs. And here's some of the settings. You can see what bin logs you have on the server. Show binary logs from inside the MySQL CLI. In this example, there's just 2 of them on the server. These file sizes are super tiny. By default, the bin logs are usually 1.1 gigs. And of course, this is showing whether or not they're encrypted. Don't ever, if for whatever reason, as a side note, not really a backups type concept, but if you ever have to delete some of the bin logs, because let's say, for example, that server is getting slammed and the disk is full, and all of a sudden you realize you've got 1,000 bin logs, don't just delete them. There's an actual purge command for getting rid of them. And if you've got 1,000 of them, which is a terabyte on the normal settings, don't just get rid of them. Don't get rid of them all at once, because all of a sudden you're telling your storage device, hey, whack that terabyte of data, do it in chunks. But anyway, you have to use the purge tool, because otherwise some of the different pieces of MySQL are like, oh, hey, I've got 100 bin logs out on the server, where are they? So use the appropriate tools. Incremental backups increase your recovery time objective, again, because the process you have to follow. You're restoring full backups, then the incremental to get to where you need to be. But again, it also helps if you've got that terabyte, petabyte of data, and doing a backup takes a long time. Maybe your write volume is really high. It might be a write-heavy database. So it's more complex, but it makes your backup time shorter. So you can restore the full backup, like I was talking about earlier, and then just apply the bin logs, and basically it's an incremental backup. Full backups and bin logs will help with your point-in-time recovery, because when you're yes, sir.
For the last point, we're replaying the bin log versus replaying the snapshot of the backup. Is the bin log easier?
So the backup, let's say it's so you still have to pull down the full backup, right? But the bin logs compared to an incremental backup, so the incremental backup, let's say you're running them once an hour. So if it's minute 59, you're almost an hour ago that you had your last incremental backup. If you're backing up the bin logs, then you've got the data right up until practically the last minute, last second, practically, just give or take. So the speed is good, probably not exactly the same. Yes, sir?
Yeah, I kind of hear you saying that bin logs are better.
Yeah. Like, it can be your incremental backups. That's the way I see it. You do your full snapshots, do your snapshots or full copies, whatever, and then keep the bin logs for, like, say, the last 24 hours, if you can. If you're a really big company, like a Shopify or whatever, you're probably only keeping bin logs around for like an hour. Actually, I think they might even be shorter. Some of those big companies have forced MySQL to have bin log rollovers be in the minutes, so because of the amount of data. But yeah, the bin logs are better. Do a full backup, keep your bin logs.
So when you say apply the binary log bin logs, so let's say I have a full backup, when you say apply the binary logs, am I overwriting the binary logs from the disk, or what is that applying?
So the bin logs that you're replaying against the database are from they're the ones you've streamed somewhere else, the ones you're backing up. As you're recovering a database, it's going to be recreating new bin logs, right? Because you've restored a full backup, which doesn't create any new bin logs, but then as you start replaying bin logs, you're telling the database, hey, make all these new changes to bring me up to date to where I wanted to be, but those are new changes. So the database is creating new bin logs, and obviously you don't want to overwrite your backup bin logs, because you've moved them somewhere else. You don't want them getting wiped out. As soon as you have an event occur, make sure you grab everything, right? Grab what you need. Grab logs off the server, grab logs off the database, the OS. Make sure you've got all your bin logs that you need. Move things off to the side so that you don't lose them, overwrite them, whatever. Because yeah, for example, while you're replaying these bin logs, it's going to be creating new bin logs that represent those new changes to the database. Does that answer all of the questions? So again, this process helps bring your recovery point objective to as close to zero as you're getting. You're ideally going to have all of the data with super minimal data loss. Just depends how fast your database is writing. You might only be losing seconds of time or minutes or whatever, but it just depends. But it's basically about as good as you're going to get. And again, as I've said, you're basically restoring the full backup. Identify the point in time so that you can tell the MySQL bin log tool where to recover to, and then feed them into the database. Things that'll specify what that objective is, where you want to recover to. Could be anything from like a dev thinking they were on a developer environment database, and maybe they're like, okay, I'm done with this data, let me truncate it and put new test data in, and little did they realize they're in a prod environment. Happens all the time. Devs do it, DBAs do it, if you're not careful. I had a talk once about something called fit acer. Basically, the point is just slow down. If you're gonna hit enter on any type, sorry for the segue, I think it's important, especially talking about disaster. Slow down. If you're about to hit enter on any type of command, that if it's on the wrong server, if one of the parameters is wrong, or you're in the wrong environment, any of those things, if it could cause damage somewhere, stop. Just verify, are you on the right server? Are all your parameters right? Is the command right? Are you in the right directory? Don't do an rm minus rf from the root directory. Like all these different things, just take a few seconds. So many companies, big to small to whatever, just a few extra seconds and you would have no longer seen that thing in the news about so-and-so being down this week. So I think we've talked about this. There's no one size fits all. Again, it depends on your needs, your RPO, RTO, all that good stuff, and what your capabilities are. Can you do snapshots? Do you have a terabyte or a petabyte or 5 gigabytes of data? Depending how big, how fast your devices are, your solution needs to fit you. And again, having those logical backups, especially if you often have like devs or whatever, hey, I lost this data, can you help me out? I need a table or a particular database. Usually something small, right? That's less than a full backup. If you find that you have those even every once in a while, do the logical backups. Like just squeeze them in somewhere, separate replica, whatever. Segue. So don't do the backups on the source or master database. Don't do the backups on the server that's taking all the production workload changes. Have a replica, if you can, have a replica just for your backups so that you can take it offline, you can lock it, you can do whatever you need to with it. Because, for example, let's say you're not doing those logical backups, but all of a sudden you just need a particular table, and it's small, and you don't want to have to recover the full and play the bin logs and then do the dump. So if you've got a replica just for backups, stop the traffic to it. Stop taking any more writes, grab whatever you need off it, do a dump, do a logical dump, physical dump, whatever. You're not impacting your production environment that way. You're not impacting your servers. There's no downtime. Life is good. So obviously you do need to lock it if you're still trying to do traffic on it. Hopefully you're not sending any writes to your replicas. It's not what they're for. You will cause problems. And of course, you can stop the slave thread to close things down temporarily. Excuse me. But best practice, please. Offsite backups, again, don't let those backups be on the same server. Sometimes you don't even want them in the same data center. I know somebody that they used to be in a data center and they had a fire. And the firemen were running into the data center with a hose that was dripping water. Like literally, we have a picture of it. We usually show it in all of our talks. Don't keep it in the same place. Put it somewhere else. If you're using cloud, that's awesome but even then you might want to move it to a different region or zone, whatever, depending how paranoid you are. It's backups, be paranoid. And you could even use a managed service for your storage if you need to, like Iron Mountain. I don't usually see the need. It just depends. Again, no one size fits all. Schedule your backups. Don't be that person that's like manually running the backups like once a day, once a week, because you're gonna forget, you're gonna get busy, whatever, you know. Schedule them. There's a ton of scheduling tools, anything from cron that's built into Linux to whatever, billions of scheduling tools. Be lazy, automate everything you possibly can, right? I love automation. I like to be lazy. And automation doesn't do human typos. If you get it right and you tested the automation thoroughly, it'll do the same thing over and over, more or less. Unless, of course, something else happens, disk failures, stuff like that. So is all of this really worth the effort? Like, this is a lot. Like, can I just say, well, I do those backups weekly, manually, or, you know, or that kind of thing? Like, it's a lot of work to do backups right. But I hope if we've got to this point, I hope I've already answered this question. If not, I've probably done a bad job. But things happen, right? Disks go bad, data centers get fires, devs, DBAs, application bugs. There's so many ways to lose your data. And nowadays, if a lot of companies nowadays, if they lost all of their data, you would put them out of business. Think about that. If you're the DBA or you're the systems engineer, and all of a sudden you lost all the data from, let's say, your servers that may be all running on MySQL, you could just put the company and yourself out of business. So, and backups are not high availability. High availability, think of like a car driving down the street, right? It's got 4 tires. That's not high availability because it needs all those 4 tires to run. But like, let's say you've got run flat tires. That's kind of high availability because the car is now in a degraded state, but you could still drive it. And like, you know, like the lug nuts on the car, there's usually multiple, you know, lug nuts on each tire. That's also redundancy, high availability kind of thing. The spare tire in the trunk, you know, is kind of like disaster recovery. It's the spare. Something goes wrong, we swap it out. But backups by themselves are not high availability. So today we covered some basics. We covered types of backups, a handful of tools, the main ones, I think. Some best practices, and was it worth the effort? Does anybody have any questions?
Yeah, that one slide, disasters and whatnot. I think I would put in malware, ransomware, encrypting all your files. That's huge.
It is.
Bigger than fires and disk failures.
Absolutely. That's an extremely good point. Malware is getting to be very bad right now. I mean, right now. It does seem to be getting worse, where some hacker is encrypting your hard drive and then demanding a ransom. A lot of big people, hospitals, corporations. Here on the East Coast, we had one of our major utility providers have it happen to them. And power on a major part of the East Coast, was it power or water? I don't know, gasoline. Our gasoline services were all locked up in several states of the US because that one company had their hard drives encrypted and somebody demanded a ransom. Backups that are off-site on an unmounted hard drive, maybe it's in a bucket somewhere, but it has to be somewhere else that's not always available on the server. So if you're always backing up to a mounted volume, unmount the volume and like move it elsewhere. Maybe even back up that volume to somewhere else. But make sure, sorry. Thank you, Dave. I hope everybody enjoyed the talk. Thank you. Dave, thank you.
And now? Okay, good. All right. All right, let's start. Who wants to hear about the boring topic of security? All right, good. All right, so let me give you a quick introduction about 2006 at MySQL EB, company behind MySQL. And then Sun Microsystems worked for Percona. And I joined Amazon Web Services as a database engineer 2 years ago. And I switched to security, doing some security work. And I'm currently leading a database security team. We are doing penetration testing. We are trying to basically find as many security issues as we can before bad guys will find it. And by the way, I'm hiring security engineers. If anyone wants to work at AWS doing penetration testing work and databases, please come see me after the talk. So what do we do? We are running database as a service. So we try to make it easier for people to start and operate relational database as a service. To start and operate specifically MySQL, we also have our own version MySQL compatible database, Aurora MySQL. All right. So I usually do that at the beginning of the talk. How many of you are running different versions of MySQL in production? Well, everyone is probably in this room worked with MySQL. That's not my point. My point is which specific version are you running? So who actually runs MySQL 8 in production? All right, good. 5.7. All right, 5.6. All right, 5.5. 5.1, 5.0, 4.1, 4.0, and 3.23. Okay, that's good. So not many people are running unsupported versions, and no one in this room, I'm kind of surprised, they're running 3.23. Right. So I started working at MySQL with version, I think it was 3.21, if I remember correctly. But it definitely worked at 3.23. It was something around 2000. So it's good that people are using the later versions, the latest versions of MySQL, because there are much less known security issues in it. And it's actually bad for, hackers. It's bad for hackers, right? So we call it bad actor. Right, a bad actor, a black hat hacker who is trying to attack MySQL. So here's the brief history of MySQL and security issues, security features in MySQL. So it all started at old version of 3.21. 3.23 was the real MySQL version with many features. And at that time, we had authentication, users, passwords, and authorizations in a form of grants. That's normal database stuff. But that was pretty much it from the security point of view. And then over the years, lots of new features started popping up in MySQL databases. 4.0, right? So 4.0 introduced encryption in flight between the client and database. You can imagine there were no such option before. And then better MySQL password hashing. And then starting 5 0.5.1, lots of new features started to appear in MySQL. Encryption, better passwords, and stuff like that. And in MySQL 8, there has been lots of new features added. But what is important, I think, is secure defaults. A database needs to be secure by default. Here's a quick outline of all the MySQL security features. Actually, probably not all, but interesting ones. So encryption, we have encryption in flight, we have encryption at rest, we have various cryptographic functions, we have authentication with a new authentication protocol, we have new authentication method, pluggable authentication, so you can even write your own if you want. And I think one of the biggest things that has been missing in MySQL for a long time is roles. Traditionally, there were no roles in MySQL, and roles appeared in MySQL 8. But what do you guys think the most important thing, security-wise? In my opinion, the most important is secure defaults. If you're running a database, you want to basically make sure that it's secure by default. And why it's important? Well, because recently we have this notification of some security company did a scan over the internet and found over 3.6 million MySQL servers exposed to the internet. So that's basically insecure default, right? So this thing probably have nothing to do with MySQL, actually. It's just a network configuration. But because lots of insecure defaults over there in the wild, it is still possible. So here's our agenda. But before we will talk about the agenda, I want to talk a little bit about what I'm going to talk about. So in this talk like this, in a state of security in MySQL 2022, it's really hard to create a very good talk which is awesome and exciting, but at the same time complete. So I was thinking to myself, well, there's this new exciting feature in MySQL 8, I should talk about that. And then I ended up with a 500 plus slides for 1 hour. That's not possible, right? And it's not exciting. So what I decided to do is I decided to focus on those 4 topics. And for each topic, I will go in to look at the security feature from attacker perspective, from a hacker perspective. What a hacker, a bad guy, can do with this. And then after we understand what is possible, we can see how the security feature applies and how it helps to prevent it. So we'll talk about encryption, authentication, authorization, and auditing. So we are here right now, and we will start with the encryption, and we will start with encryption in flight. So for a long time, the default, again, talking about secure defaults, by default, MySQL connection was not using SSL. And that means that the data is traveling over this connection, over the network, unencrypted. And let's see what that means and what an attacker, hacker can do. So I have recorded this video, and I will start this video. This is a screen recording. So basically, I'm running this MySQL 8, and you can see that SSL is not in use. And then I'm trying to select from the credit card. And on the right side, I have TCP dump running. Right? Well, it's on the left side from your perspective. I'm running TCP dump, and then with the TCP dump, I can see the traffic. And in this case, an attacker has, a black hat hacker has successfully intercepted my credit card number, which is 1, 2, 3, 4, 4, 5, 6, so on. So we have intercepted the traffic successfully. So let's take a look. Then, right, so we have this number here. We have this bad actor intercepted the traffic. So what should we do? We should always use SSL for the encryption. The good news is, starting in MySQL 5.7, we have SSL enabled by default. So every time the connection is established to MySQL, being from the application layer or from the command line or from the workbench, it's using SSL. And how do you see that? You can run \s in your command line client, and you can see that SSL is enabled. So let's repeat that. If you have an SSL enabled, this is MySQL version 5.7, but of course that all applies to 8.0. So let's repeat that test and see what an attacker can do. Again, the example for MySQL workbench. So here, I'm doing the same thing, but this time I have SSL enabled. Actually, I tried to do the select star from CC, no database selected, but you already see that the intercepted traffic is actually garbage, right? It's encrypted, and an attacker cannot directly see that. So now I'm selecting from credit card number. I can see the credit card number, but an attacker will see this piece of garbage. All right. So basically, we have successfully protected from man-in-the-middle attack, where attacker can get the TCP dump listening and see the traffic. So we have protected. So always use SSL where you can configure MySQL users with SSL. How you can do that? The best thing to do is to add require SSL when you create a user. So that means that that way we will ensure that the connection will always be encrypted. But what if the connection that it's trying to establish is not encrypted? I can always do skip SSL, right? But then in this case, even if I specify the right password, the connection will not be established. The connection will be refused to establish. So that's our SSL, require SSL piece working. We can also protect other things. You can read about that. I don't want to repeat the manual. There's a configuration options for source and replica, for MySQL replication. There is a between nodes and a cluster, etc. Yes, go ahead.
Quick question. Is there a way you can run a report what all the security defaults are? That way you're at?
That's a very good question. There are secure benchmarks that you can run that will give you very generic things about how MySQL is configured. There's a CIS benchmark which you can run to determine that. Specifically for MySQL and SSL, you can just select from the MySQL.users and see if the SSL enforcement flag is there. There's a field there that you can check. For other stuff, you can also do some manual configuration check.
Gotcha. Yeah, CIS benchmark.
Sure. All right. So what else? Encryption at rest, encryption at disk. And this is also important. Let's imagine an attacker, a bad actor, will be able to get to the database or be able to obtain a backup somehow. What this person will be able to do. And let's see. So I did this test, very simple test. I created, on a MySQL server, I created a table and I put my name there, PII data, right? So I put my name there, and then I wanted to see if I simply do a grep for that piece of data, will I see something? So again, I'm on the database server. I'm root here on the database server, and my data directory, MySQL data directory, is /data MySQL. This is where I am. And I just do a recursive grep, searching through all the files there. And I can see that there are lots of matches here. First of all, the InnoDB redo logs, the log file matches. That means that my information, my PII information is there. The binary log matches. The actual table space matches, right? And then finally, the double rate buffer matches. So lots of information has been stored there unencrypted on disk. Again, what that means is that if someone was able to obtain a backup or was able to get into the database server and copy the files, the information is there. End of game. So PII is stored on disk in clear text. How do we protect? We can use transparent database encryption. Transparent database encryption only protects from that specific scenario. Only encrypts data on disk. The data in memory is not encrypted. So if someone will be able to connect to MySQL, will be able to connect to the MySQL directly through MySQL protocol, this thing doesn't apply. You can read more online about the table space encryption and how to implement that. So there are lots of options here. You can encrypt the InnoDB files, you can encrypt binary logs, you can encrypt the regular logs, you can encrypt TMP. The different versions has different security features. I would suggest using MySQL 8.0 or Percona Server 8.0. Yes? Yes, yes, of course. So what I want to do to demonstrate here is to encrypt everything. I put this in my.cnf file. I encrypt everything, and I want to repeat this. When I encrypted everything, I repeat this test. I put my name again there, and I do a recursive grep. And now nothing is found because the data is encrypted. So when I search for a specific string, it will not be there because the data is encrypted. So in this particular case, if an attacker will be able to get the data from disk, the attacker will not be able to, unless they have a key, will be able to decrypt it. There are lots of other things about transparent database encryption. I will not be able to talk about that anymore, but important thing is if you need encryption on disk, use that. Go ahead.
Where's the key stored?
That's a good question. I had done a previous presentation with about encryption at rest. You have the option to store the keys outside of the MySQL server on a shared drive. You can store it in vaults, whatever. But I just don't have time today to talk a lot about this. So our next stop is authentication. And when we talk about auth, we usually distinguish between auth-n and auth-z. So authentication usually applies to connecting to the database username and password, and authorization applies to what user can see, what user can access, and stuff like that. So we will talk about username and password and connecting to MySQL. In security, we have these 3 A's of security: authorization, authentication, and accounting. So again, for MySQL, we have authentication, username, password. Authorization is usually grants, and accounting is auditing. So we will start with authentication and how MySQL stores the username and passwords, and how an attacker can potentially take advantage of that. So the basic MySQL auth plugins are the MySQL Monty's original creation. old password. Don't use it. It's very old. The newer implementation called MySQL native password, also don't use it. Only use in some exceptional cases where your application is enabled to use the newer one. And the recent one, which is SHA-256, caching SHA-256, which is available since MySQL 8. Again, let's look from the attacker perspective. So let's say that we create 2 users with the same password, and we use the original MySQL native password. What we will see here? We'll see the exact same hash. What that means is that there's no salt involved here. And this is actually important in a scenario where someone somehow was able to grab all your database of passwords, find one user which have password 1, and was able to get other users with the same password 1. It's actually also, there's an attack, specific attack, which is called rainbow tables. And you can use this attack to get the actual passwords from the hashes. And this is, you can also simulate that if you do select password function. That's actually been deprecated from MySQL 8, but in MySQL 5.7 you can do select password and specify the password. You will see that the same password hash will be generated. And actually this is the algorithm behind it. Right, we have run SHA-1 twice. So let's see how the newer algorithm works. So if you do the same thing and you create 2 users with the same password, you can see that the hashes, the result hashes of this new algorithm is actually different. So that means that they are salted. So this is much better algorithm. But let's see, why do we want to use this? And to answer that question, we'll need to start, how did a bad actor get a password from hash? There are basically 2 options. The first option is to brute force. And there are applications, there are open source tools available. One of them is Hashcat. In some cases, if you are able to sniff the traffic and there's no SSL enabled, then there is a specific attack, unhacks attack, that you can use. You can read them online. It's very interesting. You basically have the modified MySQL client. If you're on the same server where MySQL D is running, you can use that client and basically use this hash that you have collected and authenticate. But let's see what we can do. There's a great article here at Percona blog published in 2020 about how to brute force the MySQL passwords from hash. So I decided to give it a try, and I spin up my instance, EC2 instance with GPU. I use this P3 2x large instance with a GPU, and I installed this Hashcat open source tool, and I use the dictionary, the word dictionary. So basically, the user that we have created has password 1. And the password 1 is obviously in this word dictionary and can be recovered in less than a second. So obviously don't use password 1 as your root password. But let's add some fun to this presentation. So let's take this hash. Legacy application uses the old MySQL method. And let's say I don't know what this is. I just get this hash. So the question is, can we crack this using this inexpensive GPUs? And actually, yes. This password is 6-character password using all what we are usually required to use lowercase, uppercase, digits, and non-alphabetic characters. So I run the hashcat with the brute force option. There's no dictionary here. Dictionary didn't work. This is not a dictionary word. So I use this hashcat in a brute force mode, specified here in the options, the question mark signs actually mark what kind of characters are allowed. And then I somehow knew that this was 6 characters there. So 6-character password was cracked in 17 seconds. So let's make it better. Let's use caching share 256 password algorithm in MySQL. So I created the same user. At this point I know this password already. I created this user, and then I use this function to retrieve it, to convert it to the form that hashcat can use. So I got this long string starting with $sign $MySQL $, and I put it into hashmap. So can we crack this? Any guesses? I mean, of course we can crack it. The question is for how long? How long will it take? So my current estimation, it's still running. My current estimation is 30 days. So it's also, I would say 30 days is not good. 30 days is not good because we can use more instances, we can do distributed and stuff like that. So two conclusions here. The first conclusion is the new algorithm is significantly better than the old one in terms of protection from the brute force. The second thing is don't use 6-character passwords. All right. So Percona did a good job trying to see how long it will take. So 8-character passwords with only lower and uppercase letters and digits for the MySQL 5.7 can recover just 2 hours, and the same hash in MySQL 3.0, like caching SHA-256, 2.8 years. When I see something like 2.8 years, then it's like, wow, that's something. Of course, there can be other attacks. There can be embedded dictionaries and stuff like that. But we want to at least make it harder for bad guys to get this password. So quick recap. Use caching, share, password in MySQL. Use better passwords, and make sure MySQL.user is not equal to default. So this is a good question, right? Why does we actually have the ability to select from MySQL.user? And let's get to the second part of this presentation, which is called authorization. Authorization is all about access control and isolation. And this is my favorite part where I show you some interesting examples how, again, an attacker can take advantage of lack of isolation. So let's start with this. SQL injection. Actually, this guy is me, looking at this code like this. So this is a very simple case of SQL injection where an input from the user passed into the SQL query without any sanitation, and actually the string is being created out of that. So what we can do with it, what an attacker can do this, right? So we can add to that string. We can actually add this. We can use union here and add an additional SQL statement which will read directly from mysql.user table. And then we can see that we grab the root password, and now we know what to do with this. We run the hashcat and try to see what. But database. How do we usually configure this? Right? We configure, we have all and every privilege to the root user, and we have a specific privilege for the web. As isolated in this case, in this MySQL database. Started granting everything on the application user. And this is the wrong way of doing this. That basically means that we have no isolation anymore. But even worse than that, so if you have that user that have everything, that has insert, update, delete, select on star.star, that user can select from the mysql.user, get the password, run the hashcat, and reconnect to the database with more privileges. But even worse, you don't even need to do that. If you have grant insert, update, delete on star.star, that means that you can actually go ahead and update the password for the root user or admin user, and that's it. And you basically going from just one database access to everything else, everyone else. So this is not good for custom isolation. That's not good for any isolation between the users. And again, this example is that you can also do other thing, right? You can actually change your own permissions, your own grants, and you can become the super user on the database. So you don't even need to update the password or whatever. So how do we fix that? Well, the original way of fixing that was to get this percent signs. So you can basically do the more isolation by specifying whatever prefix you have for the database. At least that doesn't give the cross-customer isolation, but at least it will protect your users from accessing the MySQL system database, from changing the permissions and stuff like that. This is not also not good, but at least you can will not be able to create a database with this prefix. But what if we don't have a prefix? What if there's no distinct pattern in naming our database? Yes.
Sorry, I just realized. So if you've got insert on Mysql.users, is there, I can't remember, is there anything else you would need to do to upgrade a new user?
For especially in the older versions, no. You just insert into MySQL.user and that's it. If you have an access to the MySQL system database, you can do lots of different stuff.
And I'm trying to remember. I knew it worked in the old versions. Does it work on 8?
Yeah, if you have an access to the MySQL system database, it still works on 8, even though the MySQL 8 have moved to the different table space, but you have an insert. But we will talk about 8 and how we can configure that so that this whole thing will not happen. So it's very easy to make the mistake. And this is a clear privilege escalation path inside the database. If you have a global read-write access, you can update MySQL user table. You get new MySQL privileges that you're not supposed to get. So what was introduced in MySQL 8 to actually fix that? There are 3 good options here: partial revokes, roles, and dynamic privileges. So what we really want to do is we want to grant everything except in this particular case. And it was not possible before. And starting with MySQL 8.0.16, you can do that. You can grant globally except. And we want to isolate our MySQL system database to solve at least the case of MySQL privilege escalation. So if you try to do that before, like in MySQL 5.7, and you try to revoke all, and you want to revoke the privilege that you have not granted before, you will get an error. You haven't specifically granted MySQL privilege, you cannot revoke it. And in MySQL 8, you can do that as long as you enable this new partial revokes variable. So here I enable the partial revokes. I grant all on my application user, and then I can go ahead and revoke some of the privileges partially. So here's I revoked the access to MySQL system database. This is exactly what I want. And I'm trying to create a new database with an arbitrary name. And then after that, I'm trying to update MySQL.user and get my privilege escalation. I am unable to do that because this user doesn't have an access to MySQL. So this is called partial revokes. Another good thing in MySQL 8, also related to security, is MySQL role. MySQL role is a collection, a named collection of privileges. And why I started talking about this is that this is a very good way and easy way to maintain your users and to maintain these partial revokes. So what I can do is I create a new role, app role, that is supposed to go to my application user. And then in this role, I will revoke everything from MySQL database. I basically want to protect MySQL database, and I want to protect on the role level. And then I apply this role. Again, I revoke from the role, not from the user. And then I apply this to my application user. I actually need to clean up all the pre-existing grants on that user. So I revoke all first from my application user, and then I apply the role. And because the role already have this partial revokes in it, I will not be able to access my SQL database. And if I do a show grants for the app, I actually see that it's granted the role. And when I try to do the update on the MySQL user database, it will not be able to do that because the role protects me from that. All right, so for the authorization part, we were able to use the new MySQL 8 features, roles, and partial revokes to actually help with this local privilege escalation issue. So finally, talk about auditing. Very quick note on auditing. Why do we need audit log? And there are different types of logs in MySQL. There's a regionally being general log, which will store everything, very inefficient. Have been binary log, which will only store the changes coming into MySQL. And MySQL audit log has been introduced in, I think, 5.7. And Percona server made it open source. So why do we need audit log? Remember SQL injection? So we really want to find if there ever been an SQL injection. So in this case, I have enabled the audit log. This is Percona server. This is using the XML format. You can use other formats, doesn't matter. But what I'm seeing here is I'm seeing the SQL injection, which I should never see here. And SQL injection is here. I can see the username and host. But what is the most important part here? Any guesses? Exactly, timestamp. Why do we need timestamp? We need timestamp to be able to actually correlate that to other logs. Because at this point, we know that this is coming from the application. We know the host of the application, but we don't know who was the actual user that introduced that SQL injection. So this is the unique part, and this is why you really need audit log and not other type of logs. In audit log, you have timestamp, you have the query, and you also have username and password. Using those three things, you can go back to your application server if you want to do a little forensics. You go back to your application server, you see what happened at that date, and you will see the actual request. If you will dig into your web server logs, you may find at that date, you may find something that will explain this SQL injection. And then you will be able to trace it down, trace it back to the IP address of someone who did that.
Assuming all your times are in sync.
Yeah, assuming all the times in sync, you can get a window of times. You can also try to find this data somehow because you sort of have some piece of information that you need, some fingerprints that you can find. But yes, make sure that your time is in sync across the servers. Okay, I think that's all I wanted to talk about. This is my LinkedIn profile. Feel free to connect and ask any questions. And by the way, did I say that we're hiring? Yes. We're hiring security engineers. See me after the talk if you're interested. Questions? Go ahead.
So you didn't discuss certificates about
Yes.
the encryption.
Correct. I haven't discussed lots of things. I was thinking to myself, well, there are lots of other security features that came into MySQL. I was thinking, well, I will run out of time. So I had other presentations. I had a presentation before at Percona Live specifically about encryption. encryption in flight, encryption at rest, how you do the column level encryption, how do you store PHI, PII data in it. And another presentation I did on, what was that? Another topic in security, just storing PHI, PII information.
Tell people, were those talks recorded?
Correct. They have been recorded. They should be on Percona website. And the slides are available as well. All right, any other questions? All right, thank you very much.
Hello? Okay. Let's give a couple of minutes more. Well, let's start. Well, this is welcome, and thank you very much for coming here today. Um, Today we're going to talk about point-in-time recovery for MySQL. I made a joke about the presentation name. Instead of back to the future, now we are going forward to the past. My name is Pepla. I'm father of 3 kids and 3 cats, and in my spare time, I work as a consultant at Percona. You can find me at Pepla. It's a bit redundant. I'm currently located in Barcelona, and I'm Catalan, so you can, if you speak Spanish, you can ask me in Spanish if you want. Disasters happen. So failure is not an option, but is a possibility. Even if we design our system taking care of almost everything, there's always the human factor. There are bugs in the code, there are security issues. We can have SQL injection, or we can update a version that of even not our code, a product made by a third party that has a bug, and this bug makes your database inconsistent under certain circumstances. Or even there's a problem, somebody has to push code Friday in the afternoon to fix a bug because the site is down, and then there's a lot of pressure to do something. Quality assurance, you know, they are on holidays, and the code looks fine, but when you push the code, you are merging code from a different thing, and all of a sudden, something you were not expected to run in the database is running. We've seen in the past people running deletes or updates without where clause. And I've seen DBAs doing this. And I've seen DBAs doing this by accident sometimes. For example, not database related, but I removed completely one directory just because I typed the remove command and I said, oh, I have to fix it and ask for confirmation. And while I was deleting, I pressed return instead of delete, just in the middle of the removing. I removed completely the name of the file and left the directory. Okay? And it was an accident, but it happened. And I'm not talking about something that happened to somebody. This happened to me. Okay? So disasters happen. How can we avoid or reduce the impact of a disaster? Well, one option is making frequent backups. Okay? So we make frequent backups, we store the backup in a different location, but the problem is that we can't make a backup always making backups. Or in theory, we can't use the backup software to do these kind of things because backups take time. So even if you are able to start one backup after another, during the time of the backup, there's the risk of losing transactions. So there's always a gap between backups. We need a way to store all the changes that happen in the database, okay? And this is what point-in-time recovery is. Point-in-time recovery is restoring a database to a specific date and time. And very important, the specific date and time is previously unknown. You are not doing point-in-time recovery when you do a backup before pushing new code to the production environment. Or you are not doing point-in-time recovery if you, for example, make a backup before upgrading the version. Okay? Point-in-time recovery is done always when you don't know the point in time. Okay? So what do we need to do point-in-time recovery? Well, we need three things. The first one is a valid backup. Obviously, it will be used as a base for the recovery. The second one is a copy of all the executed transactions since the backup till the disaster. And the third, which is not easy at all, is identify the transaction or transactions that led to the disaster. In some cases, the third point is not really needed. For example, if the disaster is I removed physically the database files, I don't need to know which transaction caused the disaster. I just need to restore all the transactions that I have. Okay? There's no need to make the effort to identify the transaction because it's clear. And why can we do this? The good thing is that MySQL provides not only but two mechanisms to store all the changes that take place in a database. One is the Inode Logs, which are always active. And the other one is the binary logs that can be enabled or disabled. Okay. What are the Inode logs? Well, the Inode logs are a mechanism to speed up how transactions are applied in the database. Performing random writes involves a lot of different I/O operations. So if you want to perform a lot of changes, it's easier to pack those changes together in a sequential file, and when you have time, you apply those changes to the corresponding pages. And also, by doing this, you can pack changes. So for example, if you do several changes in the same page, if those changes are in the logs, they can be applied together. Okay, so you reduce the number of I/O operations by packing these operations. So in the InnoDB logs, you have everything that is written in the database. Okay, this means that every change is first written in the InnoDB logs, and then it's written in the table spaces. It's written in each of the tables or other database files. The problem, the problem is that there is not any tool that allows us to use the InnoDB logs to perform point-in-time recovery. This is not completely true. There is one tool that uses actually two tools that use the InnoDB logs to perform recovery. These tools are the database itself. When there's a crash, the database looks at the InnoDB logs and applies all the changes. And this is recovery because we have an inconsistent database and we have the InnoDB logs that we use to make it consistent. And the same with backup software, like, for example, Percon Extra Backup. This software has one of the stages is apply logs. The problem is that currently we don't have a method to permanently grab those InnoDB logs. Okay? Probably this will change, okay, in the future, but currently we don't have this method. The other alternative are the binary logs. Okay? What are the binary logs? The binary logs are a sequential log of all the executed transactions. Here, it's very important, the concept of sequential. This means that all the transactions that are executed on our database, regardless of the order the transaction started, are stored by the order the transaction was committed. Okay? So we can have a transaction that starts maybe now, but this transaction will not be written in the binary log until we commit this transaction, even if this transaction needs 1 hour to complete. Okay? And the sequentiality is very important because it allows us exactly to find the place where the disaster happened. Okay? If the binary logs would be, for example, parallel logs, it would be more complex. But as they are sequential, it's easier to identify. And why do we have the InnoDB logs and the binary logs? The main reason is the design of MySQL. If you know, MySQL has a two-layer design where you have the MySQL, the SQL engines, the SQL layer, and you have the engine layer. The InnoDB logs belong to the engine layer, while the binary logs belong to the SQL layer. Sorry. The good thing is that this means that the binary logs are engine independent. You can use the binary logs for point-in-time recovery, even for different engines than InnoDB. During this talk, we will talk mostly about InnoDB, but some of these ideas could be used for different engines too. The binary logs are logical, is a logical log, it's not physical. And when I say it's a logical log, what I mean is we store information about the logical structure of the database. We don't store information about pages or blocks. We store information about tables, rows, and database structures in general. In the first versions, the binary log was storing exactly the SQL statement that the transaction executed. Okay? But in recent versions, I think it started in 5.1, you can store row modifications. I said can is wrong. You must store the row modifications. I'm not going to explain you why, but it's more reliable using a row than statement. You can, there are three formats: statement, mixed, and row. The default used to be statement, then it switched to mixed, and in version 8 it's row. There is a lot of discussion about the performance impact of row versus statement. Some people say that a statement generates smaller binary logs than rows. Because, for example, if you run an update of 1 million rows, and this is one-liner, in the binary log, it will, in a statement, it's just update the whole table. Okay? While in the row format, you need to store all the modified rows. And this is true in the case of modifying a lot of rows. But for a lot of applications, you are modifying just one row. And what is more important, sometimes you are modifying no rows. And in the case of modifying no rows, the binary log in row format writes nothing. But in a statement, it writes the statement. So depending on your application and the patterns that your application uses, it will generate more log using a statement than using row format. And this is not about I run a query that finds no rows to modify. It also applies to queries that modify something that is already there. So if I update a value that is 1 to 1, a statement will write this into the binary log. And row will say, OK, I modified nothing, so I write nothing. Okay. And also, a statement, if the update statement needs to access 1 million rows to modify one row, if we replicate this change, we will need again to access 1 million rows to modify one row. But in the case of row format, if you access one row, you will write one, if you access 1 million rows but modify one row, you will write just one row in the binary log, and this will be replicated just as one single row. So it's not really true that a statement is best for performance. It depends on the case. For some cases, probably it will be. In other cases, it will not be. And also, remember, remember that this is a sequential log. So we write things sequentially in pages. So probably we'll pack several changes together, and the impact in performance will not be that big. Also, we need a consistent backup. We need to know the position of that backup in the binary log to avoid applying twice the same transactions. What does this mean? Sorry?
Sorry, I have a question on the last slide. Is binary log a write-ahead log? Or is it like after it's written to the binary log? Is the transaction written to the binary log after it's committed?
The transaction is written into the binary log before being committed. It appears in the binary log depending on the value of a variable called sync bin log. So the thing is that I can write into the binary log, but if I don't flush, maybe it's not written in the binary log. If you want to have 100% durability, you need to make sync bin log equals 1. Okay? But this depends also on the underlying storage. If you have batteries and these kind of things, then you can relax this. Okay? Well, we need to know the position of the backup in the binary log to avoid applying twice the same transaction. Clearly, we are going to restore a backup, and we are going to apply the transactions since that backup until the disaster. So we need to know the position of the backup, because otherwise we can either apply transactions after the backup and miss some transactions, or apply transactions twice. And this, in one case, we would have a corruption or an inconsistency, and in the other case, probably the point-in-time recovery would fail just because we are trying to modify data twice. How can we get the position of a backup? Luckily enough, almost all the tools that are able to make a consistent backup already provide this information. In the case, for example, of Percon Extra Backup, stores, sorry, there's a typo, stores the position in a file called extra backup binlog info file. Okay? MySQL dump stores the information at the end, wrong, at the beginning of the dump file. At the beginning of the dump file when you use this option, and my dumper stores the position information in the metadata file. Okay? So in any case, if we use these tools and also the enterprise backup of Oracle stores this information, we have the initial position for the recovery. Okay? To GTID or not to GTID? Well, there is no question. What is a GTID? A GTID is a global transaction identifier. A global transaction identifier means it's an identifier for each and every transaction that happens in our database. Why is it global? Is it global because it's supposed to be unique for your database in all the universe? Okay? In theory, there shouldn't be any other databases out there generating the same GTIDs that you. How is this done? There is a UUID of each database that is generated using the different factors. So in theory, your database has a unique identifier, and then you have also a sequence of transactions. So UUID plus sequence is a GTID. In the past, the positions in the database were expressed as a combination of the binlog file and the binlog position. And the binlog position was something as simple as the number of bytes of the binary log file in that moment. So if somebody says, well, file 1 position 1000, this means file 1 and the 1000 bytes. Okay? So by keeping track of all the executed GTIDs, an instance is able to get the position automatically. Here is the trick. The trick is that as I have GTIDs that identify any transaction, I know all the changes that I have executed. And I can, if I want to do point-in-time recovery, I know which changes I haven't executed yet. Okay? So this is an example that I used for the presentation. I create a table called point-in-time recovery, quite simple. I inserted 3 rows, and after that, I made a backup, simple too. I did not use anything complicated. MySQL dump, all databases, the events, routines, in a single transaction to make sure that the backup is consistent. And as I said before, I store the position in the backup. If we look at the contents of the backup, here we will see that, I'm going to move, but here we will see the GTID executed, and we also see the binary log position. So here it's the position, and here it's the binary log. How can we capture the binary logs? There are different methods to capture the binary logs. You can copy physically the binary logs, just using the operating system command. But the good thing is that MySQL bin log is a utility to process the binary logs. It has an option to read the binary logs and store them locally. So in theory, we can, in practice, we can take one database and from another server execute this command. We read from a remote server. We provide the IP address, raw format because we don't want the binary logs to be processed at all. We just read and write. And here we are mimicking the replication process. If you know, in MySQL you can set up replication that allows you to copy all the changes that happen in one database to another database. What we are doing here is acting as a replica. And to act as a replica, we need to connect to the database. I use these credentials, extremely secure. And the last 2 options is the stop never. This means that I'll be collecting the binary logs forever. And the last one is the first binary log I'm going to request. Beware, because stop never does not mean forever. Stop never means as long as I'm able to retrieve the binary logs. For example, if I stop the database, my SQL bin log will stop. Okay, and you need to restart it. Otherwise, the process of copying binary logs will not continue. If there's an incident in the network or something like that, my SQL bin log will time out. Okay, so if you are going to use my SQL bin log to grab the binary logs, you need to monitor that it is running, and if it fails, you need to go to the last file and restart it with the last file to recover it. Okay?
You mentioned it already, but I'm blanking. Which part of the stack is driving the binary log? Is it the MySQL engine or?
It's the SQL engine.
The stop
it just waits. Okay. It's a bit confusing, but it's the SQL layer. Okay, and the answer is quite simple. The binary logs are generated regardless of the engine. Okay, so if we use MyISAM or whatever engine we use, binary logs will be generated. So now the next step is we made, sorry?
With the utility you described in the previous slide, is it streaming the bit log?
Is the streaming the bill log?
Is it streaming? Like where are you putting that measuring it once bit log has been written? Is it streaming?
It's written in the actual directory. So I read the binary logs from that host and I store locally.
So is it like folding continuously as you're running?
Yes, but this is not that strange. This is something that MySQL already does for replication. So there is a protocol that supports this. When there is a change and I have a replica, I'll notify the replica. It's not like, have you something for me? Have you something for me? No, it's a communication between the server and in this case, the pseudo replica. And this communication, if there's a new binary log entry, there is a process in the server that notifies the replica and sends the binary log. So it's not a permanent polling. Okay? It's a bidirectional communication. When I have a binary log, I'll send the binary logs to the replica. Okay? This does not bring, it brings load, but it's, I don't know, maybe 1% of the CPU, or well, depending on the number of CPUs you have, but it's very few. Okay. Okay. So the next step is we already made the backup. We are capturing the binary logs, and now I insert 3 additional rows, and I truncate the table. Okay? So this is simulating a disaster. Unfortunately, disasters are not like this, tend to be a little bit more complex. But we will discuss this later. So now we have, what do we have? We have a backup, we have the binary logs, and we have a disaster. Actually, we said we need 3 things because you don't need disasters. They come, okay? What's missing, what we need now is to identify somehow the moment in time that the disaster happened. How can we do this? There is a command, show binary log events. It's a pity because I don't know if you can see it, but in the bottom part of the screen, it's here. I guess you can see it. Well, here it's, if you make the effort, you will see truncate table, okay? Okay, so this I'm not supposed to move because the recording, but here what we have here is the name of the binary log. We have the position. We have the event type, which is really important. In this case, it's a query. It's a query. It's executing something, but we also have write rows. These write rows that are applied in the table SCaLE 19 PITR are the inserts I made before. Okay, and here we have the truncate. So with show bin log events, in this case, we would retrieve the position of the disaster. So everything is fine. We are very happy. The only problem is that usually your system is really very busy. And your binary logs have maybe millions of rows. Okay? This is not going to happen. Show binary logs, show bin log events with 24 or 30 events. You have millions of events, okay? Or thousands of events. That's enough to drive you crazy trying to find the event. So here the trick is use, there's a command called pager in MySQL that allows you to define the pager. In theory, you should use more or less, but you can do some advanced things with the pager. For example, you can use grep to search things. And then when we run the show bin log events, it will search for the line that contains truncate table PITR, and it will show one row before. Okay? So in this case, again, we have the position on the two left columns, and in the first row, we have the Gtid of that change. So we can use this kind of filters to capture the position. But if we return to the previous screen and make again the effort, we see that sometimes the change is the exact SQL command is not here. Why is it's not here? It's not here because I said that the binary logs store rows. But in the case of DDLs like truncate, it stores the statement. Because at truncate, it makes no sense to store the whole removing of rows. It's easier to just store the DDL. And this means that in the event it's easy to see. But if the disaster, instead of being generated by truncate, is generated by an update without where clause that updates all the amounts of your invoices to the same amount, then you will find events like the ones there. You will find right rows events on that table. So in this case, show binary log events would not help that much. You can still do things with this information. For example, if you remember, I said that the position is the number of bytes. So if we see that the distance between two events is very big, this means that this event modified a lot of rows. Okay? So we could try to process this a little bit and get this information. The problem, again, is that probably this will return a ton of rows, and you can't create well, maybe somebody can, but it's difficult to create a pager command with grep that compares the value of the previous and gives you the number of the distance between two events. The other option we have is use again MySQL bin log. MySQL bin log initially was created as a decoder of the binary logs. Okay? So in the case of row format, you can run MySQL-b for verbose, and then base 64 output decode rows, And this will dump all the commands that were executed. In this case, I wrote a small one-liner that does something similar to the previous grep that is able to give us the Gtid, the position. We have the position because we know the binary log, and we have the position, and then we have also the Gtid. Important. This was a test, and I had just one binary log file. Sometimes you don't know when the disaster happened, and then maybe you have 300 or 3,000 binary log files. Okay, you need somehow to guess, or otherwise you need to process all the binary logs. There is no option. One of the tricks is, for example, is searching for binary log files that are really very big. Okay, because transactions are not split in the binary log. So in theory, the binary log files have a fixed size. But if we have a huge transaction, we will exceed that size. Okay? So if you look at your binary logs and all are 1 gigabyte, and you have one binary log which is 10 gigabytes, probably does the update. Okay?
If you've got multiple binary logs in your directory, do you wind up just doing an operating system command to find out what to sort them in reverse timestamp order to find out what the latest one is?
Well, the binary logs are sorted by sequential, so. And you have the date of the file. So this is, obviously, in the header of the binary log, you have timestamps and you have a lot of stuff, but if you have a ton of files, having to open them and process them is slower than just looking at the operating system. Well, finding the position is not trivial. Why? We've seen we can have multiple similar events. We can have, imagine that we have every hour we run an update that updates 100,000 rows, and one of these updates was wrong. Well, then identifying the rows is not easy. So finding exactly the offending, even writing the command to grep can be complex. Sometimes the event has several lines. It was written in several lines. So when you grep, you need to make a complex search because it's not an update of the table. It's what you're looking for is in the where, and this is the third line, for example. And sometimes you don't know this. So the DML are not visible in the show binlog events. If you have a lot of huge, massive binary log files, it can be really time-consuming to process them. Sometimes you don't know the exact syntax of the query, and something even worse. Maybe the disaster is not just one query. It's a bunch of queries executed together. It's one query that is retrieving data, then modifying one table, and another table, and another table. So identifying exactly the position can be complex. One of the clues you can use, as I said before, is the position of the following event. It's also useful to use the size of the files. It's important to understand, it's not easy to make it something that can run by automation. So this kind of recoveries, even if you try to write a run book for point-in-time recovery. It's something there are some lines you say, investigate, search for, okay? The important thing is that you need to understand the process. Because when you do this, that's a disaster. Okay, there's data loss, probably your site is down, there's business pressure, you need to fix this quick because we are losing a lot of money. So if you practice the process and you know the process, then you can speed up and reduce the time you need to fix the issue. Well, what we are going to do now is the traditional way of doing point-in-time recovery. We restore the backup. In this case, it was a dump, so I just execute the dump. And if I check the contents of the table, we see the first, second, and third rows that I inserted before the backup. Then I apply the events. I use, as I said before, Mysql bin log is a tool that decodes the binary logs and transforms them into sequences, into sentences that can be applied by the database. So in this case, what I do is Mysql bin log, dash stop position, the position we retrieved before, pipe MySQL. This applies all the changes. And if I run the query, you will see that we have first, second, third row pre-backup and the post-backup. So I did a point-in-time recovery. Life is wonderful. No.
So for clarification, that 1176 was the position right before the truncated.
Yes. Yes. We could not use the position and use the Gtid, but this is something we will discuss later. The problem with Mysql bin log is that it applies even sequentially. So imagine that we make a backup once a week, because our database is really very big, and we don't have time to make backups that often. And we have a ton of binary logs. We make backups on Sunday night. And somebody decides to break our database Saturday morning. So we have a ton of binary logs to process. If the process is sequential, it can take days to load all the binary logs. Another problem is that we can't tell Mysql bin log to stop on a Gtid. We can tell to stop on a position, but not on a Gtid. Okay? So in this case, we need to provide the binary log file and the position in the file. How can we make this faster? Well, the trick here is that the database of MySQL already knows how to apply events in parallel, because this was implemented to perform parallel replication. So what we are going to do is trick somehow the database using replication to be able to apply those events in parallel. Everybody knows what replication in MySQL is. It's just the binary logs that we've seen that are applied in our database. So the same process we did here, but it's done by MySQL itself, allows us to, I make a backup of a database, I restore the backup, I say, you're a replica, and it collects all the binary logs and apply all the binary logs. Okay? And then we have two databases that are synchronized. All the changes that are written in the source are applied on the replica. we can make the process faster by using parallel replication. To do this, we have two options. The first one, which I will describe just, is, sorry, is we create a dummy instance where the binary logs are stored. So let's imagine that we write the binary logs on a storage server. Okay, have a box that just has plenty of disk, and the binary logs are written there. I can do one thing, is I just install MySQL there. I start a dummy instance with the minimal requirements. Before starting the database, I remove the binary, if there's any binary log from the dummy instance. I move my binary logs to the location. I generate a file that is the index of the binary logs, and I start the instance. Okay? And then I tell the database that I recover from the backup to become a replica from this instance. Okay? It's funny because it will provide information about binary logs that are not binary logs, but it works. Okay? This method is very useful if you have multiple replicas that you need to rebuild. Okay? If you have a lot of replicas that you need to rebuild, you restore the backup on all the replicas, you apply the binary logs on all the replicas, then you have all the replicas are at the same level, and then you can rebuild your replication topology as you want. And as we are using Gtids, it's self. There is another method to do this, is we trick the server, making it believe that there are relay logs. So instead of taking the logs and putting the logs on a dummy server, what we do is we place the logs as if these logs were coming from a replication process. Because the replication process consists in, I connect to the source database, and I ask for the binary log, and I store this binary log in a file called relay log. And the good thing is that the format of the relay logs is identical to the format of the binary logs. So we just need to copy the files, and that's it. So in this case, what we do is, here I'll describe the process. As we want to run the process in parallel, we change the replica parallel type to logical clock. This, if you are using 5.7, change the word replica by a slave and the word source by master, okay? Because there was a change, and I'm using the recent syntax. Yes, true. Well, change the parallel type, increase the number of workers. Then we copy the binary logs. If you look, we change the name to relay bin. Anchoa is the name of my computer. It's the anchovy in Spanish. We set the ownership to MySQL. Okay. We generate the index of relay logs. We have to do one thing. There's one variable called server ID. Each server in a replication environment has to have a different server ID. As we are replicating binary logs that come from myself, what I'm doing is temporarily I change my server ID. After that, I configure replication to a non-existing host, specifying the relay log and the position 1, because I'm going to copy all the relays. I could use the position, the required position. In this case, for this example, it fit position 1 because we are running Gtid. And this is what happens. Select star. I have the 3 rows after the backup. I start a replication until the Gtid, and all the missing rows are back. After that, we just clean replication, restore the server ID to the original value, and we reset. What happens with the transactions that were executed after the disaster? Well, usually if you look, thanks that we have GTIDs, if you look at most of the documentation, they will tell you that you can use, exclude only the GTIDs of the offending transaction. By doing different methods that are explained here. But just do this if you are sure that you are creating a consistent database. Why? Because there are relationships between the content of your databases, and there are processes that do stuff with the information you have. So for example, if you have an statistics table that gives you the average amount for the invoices of the last hour, during the time you experienced the disaster, this data will be wrong. Okay? So sometimes it's not a good idea to reapply everything, even if this data is not exactly affected by the truncate or the update. Okay? You need to know the relationships internally in the database. Well, questions?
So you're saying stop instead of reapplying anything you didn't need?
Yes. I think you need to be careful with what you do. We are hiring, and feel free to contact me if you want.
There we go. Oh man, he just called the previous presentation amazing. Now there's, yeah, no pressure. That is loud. I might have to, oof. Is that loud? Ah. I talk louder than Pep does. Is there a guy back there messing with the... You can try? Keep on talking. I can do that. I can absolutely keep on talking. Let's see. Presenter view. And now you can't hear me at all. You messed it up. Oh, Kenny, too much. I guess. Is it okay for everybody else if I talk like that? Is that still too loud? She says it's okay. What about the guys in the back? Good, good. Front row. You're at a rock concert now. Okay, hang on, new window. I rarely present with, I just started moving everything over to Google Slides, so I'm slightly learning. Oh wait, doesn't this need to be, how do I make that full screen? That's not how to do that full screen. Is everybody okay with that? All right, back-to-back sessions, right? Everybody loves back-to-back sessions. Okay, let's talk query optimization in MySQL. So a little bit of a 101. How many of you in here? Well, actually, that's a stupid question. Like, how many of you in here are using MySQL? It's a stupid question. I got to stick to my slides. I have a bad habit of going off the slides, and then I run out of time. Okay, so query optimization 101. We're going to talk about all this stuff. I have 55 minutes and like 63 slides, so do the math of how we're going to go through this. This is actually a redacted training session, so a lot of what is in this material is part of our standard training that we do at Percona, which I'll get to in a second. We'll talk really quickly about how query planning takes place in MySQL. What are some of the common query mistakes that I have seen and that some of the other consultants at Percona have seen as well. How do you find unoptimized queries in your MySQL system? What are some things that you can do other than explain, which is what we're going to talk about in the first section, and then what can you do going beyond what MySQL gives you kind of at the basic level. Quick introduction. How many of you actually have heard of Percona? Everybody in the room? That slide is done. That's great. For those of you who don't know me, my name is Matthew, not Matt. That's somebody else. I've been with Percona. I just did the math, 9.67 years. I am a senior architect and senior trainer in the professional services department at Percona. I specialize in MySQL and training, so that if you do want any type of MySQL training, also proxy SQL and group replication and Percona XGBoost cluster, and if you want Mongo training or Postgres training, we do all of that now. Okay. Particularly for me, I've had MySQL experience going back as far as 2005, 2006-ish in everything from SaaS to massive sharding to hosted environments, and I even dabbled in IP telecom early on in I just graduated from the college and I hear work on this system type stuff, so I'm familiar with a lot of things. All right, let's jump into query planning. So you got a query in MySQL. Obviously, you want it to go fast, right? Otherwise, why are you using it? What's the process with MySQL when you want to know what this query, how is this query going to be executed? You ask MySQL, what do you intend to do? That starts with a keyword that's known as explain. You're going to ask MySQL, here's my query. What do you intend to do with this query? How are you going to access and find that data? MySQL is going to give you an answer. That answer could be right, it could be wrong. MySQL doesn't tell you that. MySQL just says, this is what I'm going to do. It's up to you to interpret what MySQL tells you is whether or not that's a good thing or a bad thing. Hopefully, I will show you what some of those bad things mean so that when you go see that, you can say, oh yeah, Matthew said that's a bad thing. We know we need to do something to make that query better. Like I said, it all starts with this keyword explain. Obviously, we don't have time to go through the entire user manual of what's in explain, so go check it out if there's something in here. There's a ton more. Like I said, this training material, this is usually about 3 hours long. Uh-oh. No, I'm just referencing the current version of MySQL, which is 4 years old now, which we have all kind of been, I've noticed that we all kind of been harping on that a lot, but yeah. Somebody asked early in one of the previous talks, like, who's still using MySQL 4? And I almost raised my hand and said, I have a client with MySQL 4 on Windows NT. And I was just kind of like, that's not, but yes, sadly enough, we still have, and then the ones I get are like, we're forced to use 5.6. Like, no, nothing's forcing you to use 5.6. Anyway. All right, let's take a look at this example. Hopefully everybody can see it. Apologize if you're in the back and you can't read my tiny font, but I have to smush it all in one slide. This says, my example query says explain, that's that keyword. We prefix our select statement. Actually, this works for inserts, updates, deletes, and selects. Okay, so explain in my query, and then this is the output that the optimizer is going to tell you. So this query actually goes to the optimizer. It just basically doesn't execute it. Okay, so this is not actually executing the query. This is just basically optimizer going in and saying, how am I going to find these rows? Is there an index to use? If so, let's use it. Can I use it? Is it is it the better of multiple types of indexes that are available? Those are the choices. I'll point out one red flag is this right here, where this says type ALL. That right there is, if you take away anything and you didn't know anything, take that away. Take that away that if you see ALL, that's a full table scan. That's going to read every single row in that table. Worst case scenario is it's all on disk, and you have to read all those disk IOPS and put it into the memory. Okay? Right? Which table we're using, which indexes were possible that we could have used, which one did we use, how long was that index, approximately how many rows are we going to have to read, and then a whole bunch of other stuff. Yeah? And if you want to know what the whole bunch of other stuff means, you'll have to go read the manual or have me come out and we'll go more into depth in our standard stuff. All right, so this is it. We asked MySQL, what do you intend to do? MySQL gave us this, and Matthew just said that means bad, right? So what can we do? Well, obviously we're going to have to add an index. Okay, where are we going to add the index? Ideally, we want to look for our equalities, because that's what we're filtering our data on. So let's add an index on that title column. Now, one thing I didn't show you guys was the schema makeup of that table. Okay, so we're going to try and add our index. And in this particular case, this is a unique situation, we're going to get this error message. And like I said, I didn't show you guys the schema of the table, but I can tell you that this column, title, is of type text. And a text field, does anybody know how many characters can fit into a text field? Nobody? Nobody knows? 65,535, right? Everybody knows their powers of 2, right? So there's a problem because there are internal limitations with how long an index entry can be. It's 1,000 bytes. Okay, so since this is a text field that could have up to 65,000 characters, we can't. That's obviously longer than 1,000 bytes. So this is a unique situation. Most of the time, you probably have varchar 20s, varchar 30s, things like that, and you have never run into this. But if you have really long string columns, you might have this a problem. So how do we fix that in this particular case? MySQL has something that's known as built-in prefix indexes. So I can actually say take the first 30 characters of that column and index just those. I've been told that that's a unique feature to MySQL that nobody else really has. They have the capabilities of doing that in other databases, but it's not as easy as this. So yay, love that stuff. Okay, so now we've added our index. So what I said earlier, we ask MySQL, what do you intend to do? MySQL tells us. We determine whether or not we like that answer or not. We make some kind of change. That change can be modifying the schema, or that change could be modifying the query. In some cases, that could also be modifying the data. And what I mean by that is like by archiving. Instead of having 4 billion rows on the table, now you archive off a bunch of old stuff and you now only have 1 million rows. That's a change as well. And the optimizer is going to treat that differently. Okay? So now that we've made a change, let's ask again the same exact question. What do you intend to do now? Now that I've made a change, what do you intend to do? And this obviously looks, for those of you who are nodding along, looks a lot better. Okay? This is no longer a full table scan. This is now a referential lookup. And referential lookup is an equality on a secondary index. So that's good. Right? So the amount of rows, previously we were looking at 3.3 million rows approximately. Now we're looking at approximately 4. I keep saying approximately because this is based off of statistics that the engine provides, not actual lookup values. All good? Question? The key length is 52 because this is a UTF-8 column, and a UTF-8 column can be up to 3 bytes per character. And then there's a... Oh, so that's 30. Oh, so the question is here. So this is the first 30 characters. This is not the number of bytes. This is to the first 30 characters. And so because the column type is encoded as UTF-8, that means it could be up to 3 bytes per character. Yeah. Oh, I'm sorry. My math is bad. Okay. I see your problem now. I see. You're doing the math and going 3 times 3 is 90, not 52. So it's most likely because I copied this slide from a previous training, and this number is wrong for the previous slide. So thank you for calling me out on that. But that's the question. So the question is, why is this 52? This is an older number. It's an older number because this slide used to be title 50. I used in a previous iteration. I updated it, but I didn't update this slide. So there, he caught me. Okay. So that's why that's 52. It's basically telling me the length. What's the maximum particular index length I needed to go through? So at some point, this will need to look at 52 bytes per entry to answer the question. That's really only useful when you get into composite indexes. So if you have multiple columns inside one index and you want to know how effective, like are we using all of those pieces of that multi-column index, you would need to do the math to determine, am I using this one, and that one by just doing the column, doing the key length math. Does that make sense? Or did I just confuse you even more? Okay. Sorry, I have a bad habit of that. What are some other ways that we could access this table? Primary key. So maybe I have this number cached somewhere already. So primary key. This is a constant level access. Can't go anything faster than that. You can't access an InnoDB table faster than the primary key. Right? Hopefully you're all familiar with as well. This is a wildcard expression inside MySQL. We use the %sign. This is now a range scan. So we've seen full table scans, index lookup, or a secondary index lookup, primary key lookup. This is now a range scan. Why is this a range scan? Well, it's a wildcard. So we're looking at everything from BAMB blank to BAMB ZZZZZ, right? You've also probably seen betweens, ends, greater than, less than. Those are all ranges of data that we're looking for. Why are those ranges? I go to my graphic. We use B plus trees inside InnoDB. They have limited depth. I believe it's 4, if my memory serves me correctly. My graphs are not to 4. This is my picture. If you're unfamiliar with what a B tree is, B trees have a point of entry, and then you decide whether or not you're going to go left or right. So in this case, we're looking for everything that starts with BAMB. So we ask ourselves, is BAMB less than or greater than Kill Bill? Go over here. If it's less than or greater than Casablanca, if it's less than or greater than, when we reach these leaf nodes inside InnoDB, this actually has our data. These are just road signs along the way, and then we store our data down here. So we will scan all of the pages that are in between here and here. So that's why we get a range scan. We're looking at a range of data. This type of query comes up very frequently from our support staff. Is this a range? How many of you believe this is a range query? How many of you believe this is a full, don't look, I'm sorry, well, I was going to say, how many of you believe it's a full table scan? It's like it's telling you it's a full table scan. My question is, why is this a full table scan? You can't answer any more questions. All right, there you go. So preceding wildcard. So what is this saying? When you think about, go back to our tree, what's this saying? Matthew just said we have to hit a point, and then do we go left or right? Yes, we have to go both. So that's why this ends up being a full table scan. We go to the left and scan the left half. We go to the right, scan the right half. We've effectively got a full table scan. So this one comes up frequently. This is a bad example, but this usually comes up with email addresses. So you want to say something like, find me all of my @Gmail users. So I say %sign @gmail.com inside my users database, and then they complain and they say, well, I have an index on the email column, but it's still full table scanning. This is why it has to do all of that. Yeah? This would always full table scan, yes. Yeah, if you said Fred at % and you had an index on it, then yes, you would be able to utilize the Fred part and find all the Freds and then find every wildcard after Fred, yes. Yeah. No, you would use the index. You can't use part of the index and full table scan. All right, yeah, we answered that one. Okay, this is another one that comes up. Okay. So this one is find all the movies that start with Z. The explain plan looks okay. It's not full table scanning, so yay. It's using an index, about 25,000 rows. This looks good. Yeah? I'm going to change one thing about this query. I'm going to change one thing. Watch for it. Boom. I changed one thing. All I changed was a Z to a T. And I went from using an index to a full table scan. Anybody have any idea what? Nothing else changed. He's got it right. Basically, how many movies out there start with Z? How many movies start with T? Right? So this is where you get into how your data itself is critical to how the optimizer is going to choose your index. There's a point where essentially the optimizer is trying to make a cost decision. I mean, it's a cost-based optimizer in MySQL. It's trying to make this choice of which is more expensive in terms of disk I/O, memory, CPU, all that stuff. What's more expensive? If I go to the index, scan a bunch of stuff, and then I have to go back to the primary B tree and grab all of the row data, or should I just go ahead and grab all the row data and do the filtering somewhere else? Do I want to do 2 steps? Or do I just want to do 1 step, but maybe reading a lot more information? That's essentially what this means right here. If I'm looking at if the optimizer says you're going to look at a small amount of data, the index is cheaper. Keep going, keep going, keep going. At some point, you're going to be looking at so much more data in the index, and we also have to go back to the main B tree to get the rest of the columns that you're looking for, because I don't have ID, title, and I don't have ID and production year as part of my index. The only thing that's part of my index is title. So I have to scan the title index to find all of those values, then go back to the main clustered index and find ID and production year. Those are not part of the index, so it's a two-step process. So at some point, it becomes more expensive to do both of them than it is just a full table scan. Yes?
So you were saying if you have a select statement, you only had that index to be, it would go back to the same speed as the
Yeah, if you only had select title, then that would be what's known as a covering index, and then all of the data that would be an index only scan effectively. Yeah. Depending on the size of your table. I mean, if you had a 10 megabyte table, those probably all fit inside one, not one page, but yeah, like 50 or 60 pages, yes. This is all of the rows in the table, yes. Yeah. Some of the rows, you could have one page with, every page in InnoDB is 16 kilobytes, and so you just divide that many. You have to find your row length and divide it by 16, and that's how many pages you have, yeah. Whoa, back in the back first.
So by your graph there, you're saying that as soon as it basically crosses 10% of the amount of rows, it's going to just dump trying to use the index.
I'm going to tell you that this is not an exact science graph, that I'm just illustrating that at some point that will happen. It might be 10% for this table. It might be 25% for this table. It all depends on the size of the table, the length, the row length, what indexes are available, what not available. There's a lot more to it than just a simple point. You also can't move this either. You can't. On this example, on my example data set, yes, that was the case. But again, if your data set and your table are different, then obviously that's going to change as well.
So what's
The
the solution to force an index? What is the disadvantage?
advantage of forcing an index, the disadvantage of forcing an index is that you will still do like the two-step process. So if the optimizer says it's cheaper for me to do a full table scan, but you're saying no, use this index, it might take longer. So it could be less memory, less CPU, but it'll take longer because you're having to do this two-step process to go and find all the data. There's usually a reason why you have to use force index, and it might be because your stats are out of date. So if you just did like a big bulk data load into that table, and the optimizer hasn't, or the table hasn't had a chance to refresh the stats, the optimizer might be choosing something that it doesn't know about. So it doesn't know that you just inserted 5 gigs of data, and so if you did a quick reanalysis of the table's indexes, you might fix that problem without needing to use the force index. All right, so what do you take away from this? Data is critical. So if you've got a development environment, QA environment, try your darndest to convince the upper exec people or whomever that your dev environment should be a copy of your production environment for mainly this reason. You don't want to be testing the T% case in your development environment, push that code to production and have the Z%, or testing the Z% and have the T% effect, right? Because your dev environment's only 10% of your production environment. Right? There are obviously caveats to this. I understand that if you're in healthcare or some place with PII information that you can't do that. So there are some other tricks where you can actually copy the optimizer statistics out of your production system and implant them into your dev system and then freeze them. And so you should get the same type of behavior. That's advanced, query manipulation stuff, which we can help you out with if you want to know how to do that. Input values are also critical as well. Too often I see clients that are testing the Z% case and they're not thinking about the T% case. So same situation. This query worked great in our dev environment, then we rolled it out and all hell broke loose because the first user who came along to the system typed T% and So make sure that you're actually test not only your smoke tests, but make sure you're grabbing some real world values that are coming from your users and testing with those values. All right. Good questions. A few more common query mistakes that we see, unfortunately, too often. So now you can take a look at the schema for this table. And then you can take a look at the query. This one came up, this was David's query that came up like a month or two ago. That was like, oh, we should throw that in the training. So we've got an orders table, got order ID, got an index on order ID. And there's data in this table. Select star from order where order ID equals blah, blah, blah. Why did it full table scan? Somebody said it. So how many of you believe that order ID, looking at this, is a number? So if you look at the column type here is a varchar. But what the user has requested is an integer. So internally, the optimizer, there's 3 warnings on this, by the way. So if we did a show warnings, I've redacted some of the junk around it. This is basically saying that the optimizer is having to convert the data stored inside the table as string to integer. Well, if you convert data, you can't use the index. So modifying the query in this case to include the quotes turns that into a string, and now we have string comparison, and now we can use the index. So that is a very much, got to be aware of that. Yeah. No, dates should be inside strings as well, because if you put a space in there, then for like with the timestamp, no, dates have to be in quotes as well. No. Only the difference would be if you're doing a date time versus timestamp, because date time is stored effectively as a string, but timestamp gets converted to an integer. So but that shouldn't affect anything that you're doing in there. All right, so that's a good one. How about this one? So I've got an index on production year, select star, and I'm calling this maydate function. So just so that if you don't know what that function does, it takes the year, 1922, and this is going to create a date out of it, January 1st, 1922. That's all it's doing. Is that, find everything where that's greater than a year ago. And again, full table scan. Anybody know why? You're not allowed to answer. Nope. Neither is Pep. And Kenny's not in here. Kenny's not allowed to answer questions either. Anybody know? Yeah, go ahead. No, I said it right here. Alter table, movies, add index. Possible keys is no. Yep, that's right. Yeah, why? I'm applying a function, again, on top of that column. So the index for production year is the index of 1922, 1923, 1924, over and over and over. The index is not this. Therefore, I can't use the index, because essentially the optimizer is saying I have to go to each row and run this function on every single row and then then do the comparison. Yeah? Does that make sense? Because the optimizer is looking and says, hey, I got an index here, but you're also asking me to run this function on top of that data all the time. Yeah? The simple fix in this case is to move essentially your constant value. So I want to now compare what's in my database to something better. And this still takes last year and takes the year function. So now I'm actually comparing 1922 to 1923, so on and so forth. So the rule of thumb is don't manipulate the data you're storing in your database to match your user input. You match your user input to the data in your database. If you feel like you have to manipulate the data in your database, that means you're storing the data wrong. Yeah? Yes. So it's not in here, but it's in. So in Mysql 8, since it was brought up, in MySQL 8, they introduced, well, 5.7 technically, but in MySQL 8, they introduced indexes on functions. Okay, so in MySQL 8, you can now say add index on make date, yada, yada. So you can do that now in MySQL 8. How is it implemented under the hood? It's implemented as a virtual column, which have existed since 5.7. So even back in 5.7, you could have altered this table and added a generated column of the make date function and then applied an index on top of that. And you would have effectively done the same thing. Yeah. Good? Good so far? Let's find some of these bad queries. Instead of your application and digging through logs and stuff, how can MySQL tell us? MySQL can tell us in a couple different places. One is the slow query log that's existed since the beginning of MySQL's existence, I'm pretty sure. Slow query log is a file on disk. You would need to use something like PT Query Digest from the Percona Toolkit, free open source tool written in Perl, that will essentially read the log file, parse it, and aggregate all the statistics, because the slow query log is just a never-ending linked list of the query and the stats behind executing that query. How long did it take? Did it a full table scan, et cetera, et cetera, et cetera. More, if you're in something like RDS or GCP and you don't have access to the disk, performance schema is where they're moving more and more stuff to. So there are specific tables inside the performance schema that you can query, and because everybody loves the name of tables inside the performance schema, events, statements, query, digest, history, length, foo, whatever, you might want to look at the sys schema, which comes with every version of MySQL since 5.6, because there are some very simple views inside the sys schema that make looking at that data more easily. If you don't want to do either of those, just go install PMM, and we grab all that data for you, which can use either the slow query log or the performance schema to grab and aggregate all that data. I'll show you guys a quick little screenshot here in 1 minute. With using PMM, I have not seen any. Do you know of any? I think the only, because the performance schema essentially manages itself, because performance schema will only keep a certain number of queries, depending on which table you're querying. The SQL query log will go essentially forever and forever. I've only seen more performance issues from MySQL in terms of the SQL query log. If your SQL query log grows unbounded, then it's MySQL that's having a problem. So, but if you use PMM with the SQL query log, PMM will auto-rotate your SQL query log for you. Yeah.
The only other problem, of course, is with the purposes schema is if you turn on, there's a really good one for query analysis that's turned off by default because the overhead's too high.
Yeah. I don't think PMM needs in particular PMM needs that one. But there's a few you can't get. If you turn on too much inside performance schema, yeah, you'll start hurting yourself. In Percona Server, that's what I should have asked. Who's using Percona Server? Excellent. MariaDB? Cloud hosted, like RDS, GCP. And then at some point, I'm going to ask the people who didn't on-prem. Sorry, that was the other question. On-prem? Okay, all right. Some of you didn't raise your hand, so now I'm curious as to what you're using. I thought I got them all. I thought I covered them all. All right, turning the slow query log on and off, simple enough. Where's the slow query located? Right there. This is the one you want. Long query time. That determines whether or not a query is slow or not. If a query takes longer than that amount of time, it's not slow, and therefore it's not logged. Okay? So if you set that long query time to 2, and a query takes 2.1 seconds, it won't get logged, and you will never know of its existence. Okay? Long query time equals 0 does not mean off, it means 0, which means any query that takes longer than 0 seconds, which is every query, that means every query will get logged into the slow query log, which is usually what you want. You want to know about every query, even the fast ones, because sometimes even the fast ones can be optimized in some way. Yeah? This could be fractions too. You can set 0.1 if you want to do something like that. Slow verbosity, it's a feature of Percona Server. We have full, so we have a lot more extended statistics inside the slow query log itself. I'll look at an example of that. We also do slow log sampling, so you can actually rate limit. So if you're scared of this, If you're scared of setting this to 0 and you've got 30,000 queries per second in your system, you're going to go through a slow query log very rapidly. But instead, if you still want some good stuff, you can change that to do either session sampling or query sampling. So slow rate limit depends on what that one is. So if you said slow rate limit equals 10 and you had session, it basically logs all of the queries every 10th session. Yeah? Or if you had it set to query, and then you said slow rate limit equals 100, you're going to sample 1%. Basically, every 1% of queries that come through, you'll take a sample of those. Downsides to those methods is you may miss some queries. You know, if you're only looking at every 100th query, you might, bad luck, get the same query every time. Right? Log slow stored procedure statements feature Percona server. If you have stored procedures, typically in community, you can't see any of the select statements that are inside your stored procedure. But if you have this turned on, we add those to the slow query log as well. The last one is slow log filtering. So in Percona server, you can say, I can put this to 0, log everything, but I want you to only log the ones that do full table scans, which that's pretty cool. Or only, this is actually orable, so you can pick and choose. So I only want to see the ones that are full table scan, comma, temp table on disk. So that'd be pretty neat. This is what PMM looks like. If you haven't seen PMM, come to our booth. We have PMM running in a chaos box that you can twist and tweak a whole bunch of values and stuff and see it changed instantly on the graph. So have fun with that one. This is our query analysis. We grab all that data. We can aggregate it. You can click on one of these, and it shows you more stats down here. 30 days retention by default, so you can absolutely say what happened 2 weeks ago to that same query and watch as it changes in performance over time. Oh, hey, look, there's a timer. All right, what else can we do? Other than basic explain, we have explain format equals JSON. This gives you the same information that regular explain does, but it spits it out to you in a JSON string. There's some more stuff in JSON. It's usually all this cost info and all this extra stuff over here on the side. But all of this over here is everything that you already get in a standard explain output. Why do you want to use this? In theory, you could use something like this in your CI/CD, where you're actually checking queries as they get checked into your GitHub repo or your GitLab repo and vetting them automatically, because your tooling could access a dummy system, run the explain output JSON, parse it all, and basically say, if ref is not const or primary or whatever, you know, fail the merge request or something like that. So you could really get deep into integrating. Yeah. And then, yeah, then just check against that, yeah. I would say fail to merge. If it's like a code push that I'm doing that has a new query, then I would say that would. I would say full table. Me personally, I would say full table scan. If I'm looking at if ref is all, I would say fail to merge, yeah. Or I would say something maybe, does this have? See, this is not going to have rows examined versus, because you have to actually execute for rows examined. If you had a rows examined, if you get to analyze, I would say like a rows examined versus rows affected ratio would be a bad ratio there. There was a question, yeah?
I came from my current job is ready to be and my last job we had Oracle, and Oracle had this cost number value. That number right there, that read cost.
Yep.
Is that like, is there a total cost sort of metric?
In the JSON explain plan there is, and like this one, that's what it's telling you. But this number, I can't read that number and say this is what it means, because that number has 50 different algorithm metrics behind it. Okay. Yeah, because it's a cost-based optimizer, but there's like a whole bunch of things. What? Go ahead. Yeah, it's a cost-based optimizer that's taking into account of like if there's a page already in the buffer pool, is it on disk? You can actually tweak those. Like you can actually tell MySQL, do I have SSDs or do I have spindle disks? And that will actually modify and merge those as well, which is weird. The cost numbers only really mean when you're doing like optimizer tracing, because when you do an optimizer trace, you can actually see all of the choices that the optimizer is doing, and it's really just picking the cheapest one. So you'd have to turn on optimizer tracing in order to see like, why is it choosing this one? Why was this one the cheapest one? And tracing will give you so much more information about the decisions that the optimizer is making.
Okay, so right now it's just using things
Yep.
So like, there's something else that can tell me like a score of this query is specific, but okay.
Yeah. And that score could change too. The same query, that score could change between now and 5 minutes from now. So that's why it's not as, that query will not always cost this amount. Yep. How would you find a query that's low cost but highly repetitive, meaning it executes frequently in your system, but it's still low cost? Okay. Okay, so you have a bug. So you got a bug in your code that's causing the same fast query to go more times than it should be going. I would say you would need PMM for that. You'd have to be logging every single one of those executions and then aggregate all that, and then you would throw an alarm in PMM that says if there's more than number of queries per second or per minute or whatever, you need to alarm us. Yeah. Mm-hmm. Mm. Yep.
New, for example, it only ran 20% of the time previously, and now the PT query digest is telling you it's running 50% of the time.
Yep. Yeah. So one of the other tools that I briefly mentioned was PT Query Digest, and so that one you would take your slow query log, run a report against that, and then run another report against your slow query log later, and you would see again the same stuff. That's obviously a manual process. If you had PMM, it's just always up to date. Yeah. Cool. Yep.
So PMM is how you're explaining it. Is it gonna give me like a list of queries that was run in the server, like a log?
Top 10. The first page that you look at, top 10. Actually, that says top 11, actually. I don't know why that one says 11, but that's top 11. This is in the last 12 hours. So in the last 12 hours, these are the top 11 queries that ran across my entire environment. So it's the load. So that's a combination of how long an individual query took and how many times it took. Yeah. Yep. Yep. Yes. Yeah. So you can actually click where this says load right here. You can actually click that and change this column to filter on all the different stats that we collect for queries. By default, it's load, and it's by default sorted by load, but you can change that to query count, query time, change the window to the last hour, the last 20 hours. You can come over here and filter and say, I want this cluster and only look at those datas. You can have, I only want to look at my prod environment, or I only want to look at staging environment. Yeah, all over the place, yes. It supports custom tags as well, so when you add servers, you can put custom tags as well, and you would be able to filter on custom tags too. And what AZs, or availability zones, not specifically to Amazon, but you can put availability zones in there too. All right, explain format JSON. Explain format tree. Just kind of gives you a more, I don't know, a visualization of the nested join actions that are taking place. Usually when you look at explain, they're all just kind of on that same level, and you kind of just, well, yeah, I understand they're going in that order. This is just giving you a little bit more visualization based. The spaces matter. That's not an artifact of my slides. That's actually how the spacing with the little arrows means. So this is basically saying we did a full table scan on title, and then we did filtering, and they were kind of merged together. Then we did a union up here between this result and that result, excuse me. We have the cost, we got rows. Again, those are all estimates. So it's just a little bit a different way of looking at data. There's more data to it too, yeah. They probably should be. I'll put them somewhere. I don't know where, but I'll put them somewhere. They didn't ask me or say I needed to submit them, so I will put them somewhere. You probably on my Google Drive somewhere. I mean, I'm serving this live from my Google Drive, so if you want it, I can share them with you. I don't have a link or slide share or anything to put them. Yeah. Okay. The new one, which I recently started using and actually used it very well as cannon fodder against my client to show him how bad his queries were. It's awesome. Is explain analyze. This came out in 8.0.18, so it's fairly recent. Explain analyze actually executes the query and gives you what the tree output does. But it gives you a little bit more in the sense of how many rows exactly and actual cost times. It's like preparing time and then actual execution time. I don't know. I've never tried it against a write. Thanks. I didn't try it against a write. I would imagine it's going to do something similar to how standard explain does, where if it's like an update, it's going to rewrite it as a select and do that still. Yeah, I haven't tried it as a write.
Earlier you said that the explain doesn't execute the writes. So if you're on an older version, of course, of the database, as I'm sure you're aware, if you're on an old version of MySQL, and you do an explain update, it updates the database.
What version was that?
5.6, 5.5.
If you did an explain on an update, it would actually execute it?
Explain on any type of write, and insert an update and delete, it would actually execute the command.
Really? I did not know that.
But it's on the older versions.
So at least 5, because I've done that many times on 5.7. I know that's not an issue on 5.7. Well, hopefully nobody here is running 5.6. Start over here on the left because I wasn't paying attention. The first number, so it says, so this is like what they say is like I'm trying to think of how to. I believe it's the time that it took to basically prepare, and then it was the total execution time. I know I'm not explaining that correctly, and I honestly will have to go back and look on that one. Because these two numbers those two numbers don't make sense there. This makes sense here that it took that amount of time to prepare and that amount of time to execute, but I'll have to check on the other one for you. So my apologies for that. For that understanding. Yes. Yeah.
My question was, this ties into SAMLize, explain, analyze, ties into PMM. Is that my understanding?
This information usually is already inside the slow query log. Well, let me take that back. That's not correct. So like the slow query log is not going to contain the fact that you took a step to unionize two things together and it took a step to do this, so on and so forth. The slow query log is not going to have that information in it. So therefore, PMM would not have that information, no. But PMM will have the query in it. So obviously the query will still show up, and you would be able to click on the button that says, show me an example of that query, and then you could copy it and paste it and go in. You can run and explain live from inside PMM, but we have not expanded it to be explain analyze yet. I don't know. There will be a lot of overhead. I know in Percona Server you can turn on query profiling for the slow query log, but that would be a lot of extra overhead. But that's still not the same thing as what we're seeing here. Yeah.
So, if I explain the update statement, let's say, so it's going to actually update.
No. Old version of MySQL. Not 5.7, not 8.0. That is a bug from an old version of MySQL. But even, so I'm sorry, yes, if you explain analyze, yes, it will execute the update, yes.
So we have probably
I would say that if you wanted to explain, analyze an update statement, that you yourself could just turn it into a select, because an update is essentially a read and then update, because we have to find the row first. So if you just took your update set whatever where something, you could just turn that into a select where something, and at least you've got stage 1 out of that update handled. And then past that is just the updating and the actual writing part.
In the old versions, when we have that issue where the explain will do the actual change, you, the user, the VA, would have to rewrite the query. So instead of doing select,
Yeah, do a select, yeah.
the same clause, the same table.
Yep.
As you said, it's the old versions.
Yep. Unless you're doing an explain analyze. So if we do an explain analyze on an update, that will execute because we know an analyze has to execute it. You could. Yeah. No, you'd have to write a tool for that. Yeah. No, PT Query Digest, you can connect PT Query Digest to a running MySQL server and it will run the explain for you, but it doesn't support explain analyze yet. Yeah. You could, because PT Query Digest is written in Perl, you could edit the Perl and just find where it executes the explain and just put format equals analyze in front of it and you'll get that out. Just change the code. Oh, it's not going to know those though. Yeah. Yeah. It's a little hacky. You could, but it's a little hacky. All right, going beyond explain. So explain doesn't really give you, explain itself doesn't give you post execution analysis unless you're doing explain analyze. What are some other things that we can do to find out really what did that query do? Okay. The first one that I want to explain is our handler stats. So contrary to popular belief, InnoDB is still technically a plugin to MySQL. It's just now a required plugin into MySQL. It still behaves as a pluggable engine. Whenever you write a query and it's sent to the optimizer is turning your SQL into a series of API calls. Those API calls are what go down to an engine, whether you're using InnoDB, MyRocks, or whatever. Engines just implement API function calls. So when you say something like, I want to select from this table, the optimizer says, oh, there's an index. I'm going to call this function on the engine and say, hey, Mr. Engine, find this data using this index. The optimizer decides the index to use. The engine does not make that decision. Okay? So you can count, well, MySQL is already doing this for you, but you can actually see the counters every time the optimizer has to call one of those particular API calls down to the engine to fetch data. These are both session and global. So you can do flush status and reset the counters for your session, execute some query, look at the counters, and you can say something like handler read random next is all numbers and everything else is 0. That means that we did a full table scan because this is random data. We don't like random data. Yeah? Very nicely, these are also automatically grabbed by PMM. It's usually the first graph I go to when I'm doing analysis on a client's machine, is I go look at these globally, and right off the bat, I can say, on average, you have more queries that don't use indexes than do use indexes. You have a query problem, not a hardware problem in most cases. Yeah, usually. If that read random next is the highest graph line on that, we got a query problem. Let's fix your queries. Fixing queries is so much cheaper than adding CPU or adding RAM. You can also do profiling. If an Oracle engineer wants to tell me why you're deprecating this, I'll fight you. This is so easy. But if you do set profiling, even on 8, it says deprecated. Like, no, it's so easy. The performance schema way is so kludgy and cumbersome. This is easy. Turn it on, run your query, look at the profile. Done. Profiling is all the different stages that your query took during its execution. Checking permissions, opening the table, optimizing it. Ooh, lovely. Creating temporary table. Sorting. Ooh. Converting heap to my ISAM. This is old. Anybody know what that means? The gentleman laughing, what's it mean? Well, no. What's it really mean? So it's 5.7. Yeah, so this is a 5.7 server. So anybody know what converting heap to my ISAM might mean? I'm gonna take a guess. So think of this one, and now think of that one. Go ahead. So this is a temporary table in memory, and then this is a temporary table on disk. So that's what that is. Now, 1/10 of a second, Now, on a system that I jumped on and did this on, that took the majority of this time. So if you see create a converting heap to my ISAM and it takes 76 seconds, okay, either A, the table is giant and has to be spilled over to temporary on disk, or in my case, the SAN that they were mounted on was not configured correctly. And I got to use this as cannon fodder to their SAN engineer who swore to me that I had the best performing disks mounted on the database server. He had it misconfigured. I saw this, and then I took sysbench, and I did some basic file-o tests, and I said, dude, this SAN can't write faster than 50 megabytes a second. You can't tell me that I have the best out of this EMC multi-million-dollar SAN. And he was like, and then like an hour later, I get a message, and he's like, yeah, okay, so I didn't have this thing configured correctly, try it again, and boop, magic. Look at that. Not everything, every query will not go through there are certainly some stages missing on here. Okay, so if your query doesn't do a temporary table on disk, you're not going to see that stage. The other one that I got once was in the checking permissions. I got a checking permissions that took 10 seconds. I was like, why does it take 10 seconds to check permissions? That should be really fast. Turns out that client was using host name-based user accounts. And every time that you logged into MySQL, it has to do a reverse DNS check. Their DNS, internal DNS, was having issues. Slow queries. Who would have thunk it? But profiling worked out great. Yeah. They are, but I was still just like, why is this query running slow? And it's just like, because, yeah, just, yeah.
I'm not sure if you have time to deal with this, but you should be running a production database.
Mm-mm.
If you're not a DBA, would you have permissions to turn this on?
You could, no, if you are just a regular app user, you can profile your own queries. I'm pretty sure you can profile your own queries. There's nothing sensitive in it that should prevent you from doing that. None. It's just for your it's for your session. It's a per session. So I would turn it on for my session, and then any queries that I ran would be profiled, and the profile would be recorded or saved in memory. So as long as you don't turn on profile and then go run a gajillion queries, you're going to be fine. No, I don't think you can. I don't think you can turn profiling on globally. I wouldn't want to either. I think at Percona server, actually you can. In Percona server, you can turn on profiling globally, and it'll be in the slow query log. I would not do that, though. That would be some big overhead. Maybe your dev environment where nobody cares, but not production. Done. 54 minutes. Sweet. If you have questions, obviously still questions. I am extremely active in our forums, and our forums are extremely active themselves. It's free community support by people like me and Pep and the other people at Percona. So if you've got questions about MySQL, Maria, Mongo, Postgres, you want to know what the next hot movie is? No, I don't think we actually do have an uncategorized category, so but whatever. Is there a SCaLE place for me to upload them to? Okay. Okay. There'll be a place for it. I will do that. For those who want the slides, I will do what he says. Not at all. All built using open source software and our stuff as well. Everything that we do is on GitHub, basically. Everything we do is open source. It's Grafana with a bunch of stuff that we've added onto it to make it better. It's yeah, don't go to any more talks. SSH right now and go do it. If you're are you in Amazon or on-prem? Or GCP? What are you? Neither? What are you on your laptop? What are you running your production system on? You don't have a production system? Okay. Okay, never mind. If you're in Amazon, we have an AMI that's published. So you can just one-click deploy, but it's usually a Docker container. Just go, it's like 4 lines, copy paste out of our doc. I use our documentation in my classes to point out the fact that it's copy paste, copy paste, copy paste. You got PMM running. So very simple. It's an agent, so you install the agent on your MySQL server. They communicate back and forth, so on and so forth. If you don't like agents, like this guy's shaking his head, we does do remote as well. So if you have like, you have your PMM server, and if you have like an Amazon RDS or a GCP or basically a MySQL server anywhere in the world that has internet access, you can click add remote instance, and it'll connect and it'll start scraping the data. Doesn't scale as well, and you miss out on all the CPU, disk, memory, all that stuff. Yeah. Hmm? Is rudimentary, yes. You know how many people have ever commented on my B-tree design? You are literally the only person in the 14 years I've been doing MySQL that has commented on my B-tree design. And that's, you win the award for that. But most of the time people don't even know what a B-tree is. And so my rudimentary, the first time I said it, I got slammed by someone who said, actually, they're B plus trees, because I was originally just trying to be high level and talk, and I was like, they're B trees and da 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 da. And so actually, they're B plus trees. Okay, great. Now I went and I updated my slides so they are B plus trees, and then yes, but you are correct. Yes, you are correct. Now I have to go update my slides, and I have to go pull up Draw.io and draw new trees. But yes, cool. I'll be down at the booth. I should be at our booth. We have a booth. If you go downstairs, we're in the booth right next to MySQL guys. So if you got questions, come ask us. That's why we're here. We're hiring. If you know MySQL, Postgres, or Mongo, come talk to us as well. We're a work-from-home remote company, so come talk. Who's up next? You, Pep? Pep's going to go, and he'll be right back.
Hello, hello, hello. No. My problem is that my glasses are, these are for medium distance. Actually, I need these glasses to see the screen, but then I can see, and I should use the progressive ones, but I don't like. Well, let's start another backup talks today. I need some MySQL backup strategies and methods. My name is Pepla. I'm father of 3 kids and 3 cats. And in my spare time, I'm a consultant at Percona. And this talk is dedicated to my parents for obvious reasons. Well, why your backup strategy is probably wrong. What's a strategy? Strategy is the skill of making or carrying out plans to achieve a goal. So backups are not a goal. You don't get up in the morning and say, my goal for today is making a backup. Okay. A goal is to protect your data. A goal is to ensure that your business is up and running. A goal even is to achieve legal compliance or some sort of regulation. But backups per se are not a goal. And if they are not a goal, they are not subject of a strategy. You should focus on something that is a goal. And a goal is, for example, recovery. When something happens, you should focus on recovery because this is a real problem. Having a backup is not a problem. Actually, I used to say that if in 99% of your backups fail, but you succeed one recovery, that's fine. If 99% of your backups work, but you fail one recovery, you have a problem. Okay? This is an edge case, obviously. So you should have a recovery strategy. And also interesting the difference for me that I'm not English native, the difference between recover and restore is very interesting because usually when we focus on backups, we focus on restore. We focus on returning something or someone to an earlier good condition. So I have a backup 1 week ago, I restore the backup, that's all. Well, this is not true. Depending on your business, you will restore the data, but your business will not recover because you have 1 week of data loss. Okay? So the really important thing is to recover, not to restore the data. And the problem is that the amount of different things that can happen is huge. You can have a disaster, you can have a criminal attack, you can have a nature disaster, employees that are not happy or are simply crazy, hardware failures, wars, major nature disasters. So, and you can have even combinations of these kind of things, or even situations you can't plan in advance. So absolute protection is impossible. Okay? And if you try, you have to pay a lot of money. So the first thing you need to do is to define the set of incidents or the types of incidents you want to protect yourself. For example, those which are more possible, those that bring higher risk, or just a combination of cost versus risk. So you are willing to assume that a server can crash and the data loss is not bad for you. Don't make backups. This happens, for example, on development environments or test environments. You don't make backups, but it can also happen on old data environments used for reporting. So, well, if you lost that data, you can't do the reporting, but that's something you can live with. And then you have to design the backup restore availability methodologies to ensure that you are able to recover from those different types of incidents. And, well, backups, we can have different types of backups. A database usually consists in 2 types of files. On one side, we have the DB files, which contain the data. And on the other side, we have log files, which are usually used for to store data temporarily and are used for consistency. This is a drawing of that model. In the log files, writes are sequential and all the transactions are written, and in the DB files, the writes are random. If we want to make a cold backup, what we do is somehow freeze writes, and then we copy everything. Usually, the traditional method to do cold backups was to stop the database. Okay, but you could perform a full cold backup without stopping the database, as long as you make sure that everything has been flushed into disk. Okay. Hot backups copy the data files, ignoring the changes. As we have the data files that contain the data, and we have the log files that contain the changes, what we do is we copy everything without trying to be consistent, and then with the log entries, we make this copy of the data files, we turn it into something consistent. Okay? And there's something I like to call the warm backup. A warm backup.
Sorry, can I ask you a question? So, the previous slide. So I didn't realize that, so like what, extra backup doesn't make a consistent backup until it's applied to logs.
Exactly.
I don't know if I remembered that. I definitely didn't remember it.
A cold backup, a warm backup is a cold backup without closing the database or closing it for a shorter period of time. For example, snapshots are a warm backup because you don't close the database, but you need recovery. Okay? And there's also one method which is quite ugly, but can be very effective if you have to make a backup of a huge database, is using, for example, rsync with the database open. And you transfer the huge files that are never modified via rsync with the database open, and then you close the database and transfer the rest of the files. Okay?
I've actually had one scenario where a snapshot that I did while the database was running wasn't consistent. Sorry, it failed to achieve consistency when it came back up.
Well, this depends on the technology used for the snapshot. Probably it was a snapshot in virtualization or GCP. Yes, sometimes this fails because it's not a storage level snapshot. And then it's
It's not a storage
Not, it's a virtual storage level snapshot, okay? So the problem here is that you need to make sure that different physical storage are snapshot at the same time. So it's the same example that you have, for example, I don't like snapshots because if somebody writes something for whatever reason in a different file system, then the snapshot is not consistent. And you discover this when you, and this happens very often in VMware and things like that, that the snapshots are made on data stores, and for whatever reason the server is using more storage, then you create another file on a data store. The operating system sees those two files as a single disk, for example, or is able to, via LVM, to merge them into the same file system, but VMware has two files, and creating a consistent snapshot of two files placed in two different data stores is complex. Okay. Another option, sometimes people tries to avoid making backups by using replication. So I have 20 replicas, no problem. If something fails, I can just promote one of the replicas. But this is protecting us from a reduced set of incidents. And it provides a false sense of protection. If somebody drops one table, it will be replicated immediately. Okay, so if we don't want to replicate it immediately, we can use delayed replicas. How much delay? Because sometimes things happen on Friday, and people realize it on Monday. So 2 days? And if somebody executed an update and corrupted data, so the amount, as I said, the amount of incidents is really very high. So, and very often the delayed replica feels like security. And we have logical backups and physical backups. What logical backup is, usually is defined as generating the SQL code needed to rebuild the database. But this is no longer true. Originally, logical backups in MySQL were performed by MySQL DOM that generated a SQL file that you could run on the database immediately. But this is not happening anymore with advanced tools like MyDumper or the MySQL shell and DOM utilities. What these utilities do is they use the same methods to extract the data than MySQL DOM. This is queries. But this data is stored on intermediate files that do not contain SQL statements. So usually you have metadata plus the content of the database. So I prefer to define logical backup, logical and restore operations that execute SQL code to extract the data in the case of the backup, and SQL code to rebuild and load the data in the case of the restore. Logical backups usually are small in size. In the case of MySQL, they benefit from the MySQL approach to the multi-versions due to the fact that do not require logs. In other technologies, logical backups require a log at the database level, but due to the fact that repeatable read is implemented as a snapshot at database level in MySQL, you can use repeatable read as a method to create an image of the database. The problem with logical backups is that rebuilding or restoring the backup can take really a long time because you need to reinsert all the data and you need to recreate all the database structures, indexes, and so are really good for partial recovery. It's very easy to recover with just one table. Usually you have a readable, human readable copy of the data, which is very good. For example, if you need to make a partial recovery, but not in the sense of recovering one table, but in the sense of recovering a bunch of rows from one table, okay? In MySQL, the impact is really low, so it's just one query that runs. And the last thing is that you need a living instance to recover. So you need to install MySQL, and you need to start MySQL and create a MySQL instance to recover the logical backup. Between the logical tools, the first one is the good and old MySQL dump. The problem with MySQL dump is just one thread, just one file. It's very easy to stream MySQL dump using netcat. So you can do MySQL dump, pipe, netcat, send to another server, and then apply it at the same time. You can use it also to dump only the table definitions. And there are options which are not really used very often, but are interesting. You can, for example, generate delimited data using dash tab.
And actually, you can just dump the data also. Right?
Mm-hmm.
You can dump the schema or the data or both.
You can dump the schema and the data, or if you dump delimited data only, you just dump the data. And recovery can be very lengthy. MySQL pump is the first Oracle into to have parallel dump. It has some interesting features. For example, MySQL dump dumps or used to dump the user table. Instead, MySQL pump dumps the user creation sentences. Okay. It supports compression. It supports advanced object filtering. You can define patterns for filtering, but the problem is that it is not valid for creating a replica because it does not return the position. So in theory, it's consistent, but yes. MyDumper is an open source tool. Actually, there are two tools, MyDumper and MyLoader. It's actively maintained by the community. And I say actively because it's a project that has been sleeping for some time, but now it's quite active and some interesting features have been added recently. It allows you to perform parallel backup. It allows you to perform parallel restore. It allows you to make a consistent backup. You make filter the tables and the objects you are going to process using Perl-compatible regular expressions. It generates multiple files, and it also allows you to stream the backup. The way the backup is streamed is quite interesting because what MyDumper does is it performs the backup in parallel locally, generates the files locally, and then there's a thread that takes every file and sends it to the destination. Okay, so there's an additional thread that takes care of the streaming.
So is the stream single-threaded?
Yes, but the stream is always single-threaded because usually it's the network. So yes, yes, but in the case of my dumper, there's a specific thread for the streaming. MySQL shell, it has a set of utilities to dump load tables, schemas, and instances. In the case of the export, it supports multiple formats. This means that the data is exported and you can define the delimiters and things like that. It also supports things like rate limits to avoid loading too much the server. It also supports storing in S3 compatible storage. It can make a consistent backup, and the utilities are, there are different utilities. You have a load dump to load a dump, and then you can dump an instance, you can dump schemas, you can dump tables, and you can export. That is the one that generates multiple dialects. TSV is tab-separated values. Physical backups perform file or block-based operations to do the backup and the restore. I divide the physical backups in two types. The ones that have awareness of the database and the ones who don't have awareness of the database structure. So the snapshots are the main hot backup, physical hot backup that exists. But as we said before, they are not aware of the database. They perform the snapshot the same way. And for example, they don't check if all the files belong to the same snapshot. This is something you have to program separately. And also, if for whatever reason you are forced to have files into different storage types, then probably creating a snapshot will become something impossible, or at least very difficult.
So in that case, though, if it is onto your storage devices, if you freeze the file systems, then it should be okay, right?
But how you make sure that you are freezing in the same moment of time?
The same way.
Moment of time.
Well, I'm flushing the disk.
The two disks. You flush one and then flush the other. They are not consistent anymore. It's like copying the okay. And well, between the hot backup, physical hot backup tools, we have Percon Extra Backup, we have MySQL Enterprise Backup, and we have the clone plugin. What does awareness mean? Each database page has a LSN. This is the last sequence number. It just tells us the number of bytes written into I was going to say the binary logs, no, it's into the Inode Logs. So it's quite simple. It's a number that it always grows, and it is used to identify if a page or a block is newer or older than another. Okay. If we are aware, we can make an inconsistent backup and turn it into consistent. And for each log entry that we have, we can compare the database blocks and say, okay, this log entry needs to be applied or not. Why do we need this? We need this because in the database, lots of changes take place at the same time. So we have concurrency, lots of transactions with different lengths are executed in parallel. What happens when there's a crash? When there's a crash, we have a bunch of transactions that were committed and some transactions that were not committed. And we also have information stored in the log files. So with all this information, we are able to perform the recovery operation and roll back the yellow transactions that did not complete. So this is the situation when we boot after a crash. And I was explaining this because when we perform a backup, we do exactly the same. We finish the backup in one moment of time. So instead of having the crash here, we could say backup end. And when we restore the backup, what we do is we remove the partial transactions. Okay? The Percona extra backup, I like to call it the Swiss Army knife of MySQL backups because you may do almost everything. You can perform a full backup, you can perform an incremental, you can perform a partial restore, you can encrypt your backups, you can make backups to the cloud, you can compress the backups. It's portable. You can make a backup from one technology and, from one operating system and move to another operating system as long as they are little endian or big endian both the same. Okay. So for example, I've been using extra backup to restore backups on Windows, okay, even if there's no version of Percona extra backup for Windows, because you can use it to go cross between Windows and Linux. Yes. You need to do some tricks, but you can do it. You can do it because the InnoDB files are compatible. So as long as you have a Linux machine where you can see the volume, the Windows volume, you can. Okay. You can stream backups. It's compatible with Oracle MySQL and Percona Server for MySQL. It used to be compatible with MariaDB, but that's no longer true. And it's free open source. To make a backup, we take the following steps. First, we make the backup. After that, we prepare the backup. Preparing the backup is what I showed yesterday, is applying all the changes and then rolling back all the transactions that were cut in the middle of the end of the backup. And then we can restore the backup wherever we want. The next tool is MySQL Enterprise Backup. It's a licensed software. It's multi-platform. It supports Unix, Linux, and Windows. It also supports backup to tape using Oracle technology. And it also supports, and this is really very interesting, binary and relay log backup. So when you perform a backup, you can also copy the binary logs and the relay logs. This also can be done with my dumper.
I have a quick question about applying the logs to make the backup, the extra backup consistent. I don't remember. Would you do it at the backup time or only if you need to restore?
Usually you do it when you need to restore.
But you could do it at the backup time, which would
No, you could do it after the backup. You can run the prepare.
so that if you ever do have to restore, you're reducing your recovery time.
Yes, but you can you can do a partial prepare because this way you can do incrementals. Okay, in the prepare stage you do two things. You do the apply logs and then you do the rollback of the pending transactions. Okay, there's an option that is just apply and don't do the rollback. Okay. backups, you can still apply them. Okay. And the way InnoDB logs are being treated is changing. So for example, now the new versions are already able to dump the InnoDB logs. So the dump that extra backup did originally is no longer needed. You can start the backup and use the dump provided by MySQL. This is a new. When you make a backup using extra backup, usually what you do is you copy the data files, and also you need to copy the redo logs, the InnoDB logs. This is no longer needed. Why? Because you can tell MySQL to do it, to copy the InnoDB log somewhere. This is a new feature. So it allows you to, so you just need to, this is why I said before that this is changing. And probably this means that in the future we will have a sort of InnoDB logs based replication. Because otherwise it makes no sense to implement this. Well, it makes sense for the enterprise backup, but if you want to create an InnoDB, real InnoDB cluster, then you use these two for replicating stuff, okay? The last, but not least, is the clone plugin. It's mostly used to rebuild instances in group replication, but it also allows local cloning to a directory. Don't try this approach. Test and document your recovery procedures. Disasters always happen in the worst moment. And when there's a disaster, you need time to decide. You don't have time to do research or learn how to restore. And also something very important, if the crisis is huge, you need to involve business. Because if the backup will take 3 days to restore, probably you need to decide the order you restore, and you need to make some compromises that are beyond the job of a DBA. I enjoy saying that the backups are like the Schrödinger cat, because a backup can suffer of quantum superposition. It was completed successfully, and you can restore it in a relevant time. What does this mean? Maybe it takes too long to restore. If you made the backup using MySQL dump, or it's an incremental backup, and you say, okay, I make a full backup every month, and I do incrementals every hour. Well, restoring this will take a long time, for sure. Or there's something missing in the backup. Or there's a bug in the backup software. And this happens, unfortunately, quite often with the new policy of MySQL of implementing future changes in minor versions. We've seen with Percon Extra Backup that actually we were forced to add a feature that does not allow you to perform a backup on a version of MySQL higher than Extra Backup.
And that applies to the point release. And that applies to the point release. So extra backup has to be updated with every single point release. Is that what you're saying?
It has to be. It has to be. You can say, go ahead and make the backup. You can, but as a default, it checks the version. And it does because we discovered one feature that made backups complete successfully, but they were not able to be restored due to one change that MySQL added. Okay? Or something as stupid as the infrastructure is not available. So sometimes you make backups, but you don't have a support contract. And your on-premise server crashes, and then the provider says that it will need 3 weeks to deliver a server like this. Okay? Questions? I've been quite quick.
Actually, wouldn't mind talking more about the snapshots.
Unless you have any questions. I was just going to point out that it takes too long. So years ago, I was working in a place where we had a Mysql box that was just wrapped out as far as how much capacity you could do. And I did a test restore, and it took 5 days.
Yeah.
And you guys like, 5 days, I don't even need to start that. I need to finish my resume because we're out of business, right? For Code Extra Backup, though, I was able to go through and use that. Restore almost took the 10 minutes it took me to copy data.
I was manager at a company which was quite successful, but they were quite, they had problems with treasury and the money, and they needed to work every day, and they could not stop for more than 3 days. If they stop for more than 3 days, they can't return to the business because they don't have enough cash. So, and it was a large company, with maybe 400 million euros per year of revenue, but it was like because they had very low margins, and then for them being able to recover quickly was critical.
The snapshots. Can we talk more about the consistency of snapshots? So if you're using LVM and you've got multiple devices merged together,
No, because it's LBM who does the snapshot. Okay, so LBM is able to control the snapshot because LBM, LBM is quite similar to a database. You have the files, but you have a log. Okay, so it's able to perform a snapshot using different devices. What I'm saying is, if you are using, for example, a snapshot on storage, and over that storage you have LVM. Okay? And these storage actually are 2 network storages. So how you make a snapshot and make sure that this snapshot is good?
you're saying basically if you're using a SAN,
Or 2 SANs on the same LBM volume, okay? And sometimes this happens with things like VMware, where you have data stores, and also at the same time, very often the providers try to move the snapshot to the lower level. Okay, so you think you're making a snapshot on VMware, but there's a driver that moves the snapshot to, okay. So snapshots you have to test to make sure that are consistent.
so what about like GCP, AWS, whatever, snapshots? So if it's like,
On the paper, it's safe. We've seen in RDS, I think it was in RDS, I don't remember if it was RDS or Aurora, an instance running on X3. Okay, the underlying file system was X3. The underlying file system, and this brought a lot of performance issues. So with those providers, the problem is that you have no visibility. You have what they say. And this means that usually snapshots are reliable, but you don't know if the underlying storage is 100% reliable. I'm talking about, for example, EC2 instances. A different thing is RDS. If they say the snapshot is consistent, it should be consistent. Okay? Because they are selling this as a consistent snapshot.
The aware type category at that point. So with GCP, for example, I did a snap where I think I think at that point in time, I still had the database running, the service, and I did a snap. Most of the time it worked fine, but I had once where, it failed. The backup completed successfully,
But
the
it failed.
database said no. So then I wound up, shutting down the server, grabbing a lock, flushing everything, shutting down the service, freezing the disk, and then backing up, then taking a snap rather, and then unwinding it all. Do you think it's possible to do less? Like, what would you do if somebody needed snaps on GCP? I mean, granted, you can always use a replica, right? So, but the problem
Probably I would use a replica.
it's easy.
It's easy. Otherwise, why are you using snapshots? I mean,
Disaster recovery.
yes, but why are you using snapshots instead of using Percon Extra Backup?
So in this particular case, the data was in the size of, it was over a terabyte of data. And the extra backup, I don't remember how long it would take for the terabyte of data.
Well, it depends on the parallelism and how fast are your disks.
So how fast do you usually see good disks in GCP backup a terabyte? I don't remember.
I don't have a number for GCP, but I've seen terabyte-size backups running really, really very fast.
Everything's relative.
An hour or sort of 1 hour, yes.
Because in this case,
I mean, I'm not saying that the snapshots are not good. What I'm saying is that the snapshots, yes. If it's a snapshot provided by, it's not a snapshot provided for the database. What I'm saying is if it's cloud SQL snapshot, then it should work. Because they have methods to make sure that everything is flushed, and when everything is flushed, it's really flushed. Because, and this can happen, the file system driver for your storage tells you that it's flushing, and it's not flushing.
yeah, so I was syncing, I was running the sync command, I was running the flush tables with relock.
It can happen that it ignores the sync.
What, like if it's buried backed up cache?
Or the file system driver. Okay. Thank you very much.
Hello, hello, hello. Do you hear it? Is there delay? No. Okay. Too loud, too quiet? Perfect, thank you. Not a lot of people yet. Yes. Yeah, it seems so. And it's Friday night. 4. So I'll start in a minute or so. I don't have a mouse clicker. Unless... Nope. So maybe some questions that I have for you in the meantime. So you can interrupt me at any time, right? If you have questions. But maybe I have some questions for you. So who's using MySQL in this room? Okay, some people are not. Okay, and from those who are using MySQL, who's using replication? MySQL replication. Okay, most of everybody. And then from the people who are using replication, who's using replica set, cluster, or cluster set? No, that's Galera. That's Galera. Okay, but that's good to know. So have you heard about it, or you're using it? But you're using InnoDB cluster then? Okay, so good, we have a user. Are you using InnoDB cluster set? So that's what the talk is about today. So have you heard about group replication and ExtraDB cluster from Procona? Good, good. Oh no, thank you. So need to change, and I need to be quick. Okay, so good. So some people have heard about it, are using it, some not. So good. So we're a small group. So if you have, just feel free and talk, right? I am a person with a lot of kind of slides, and I'm skipping some of them already because of audience, which is fine. But first, before I want to start, so I'm going to start talking about database architectures, and I'm one of the product managers at MySQL, and one of my products is MySQL Replication, high availability, middleware products. So that's where I'm a product manager of at Oracle. And the database architectures that I'm talking about is mainly high availability and disaster recovery solutions. So everything that I'll talk about, and it's not very clear, I'm not trying to sell you anything, I'm just trying to show you some products that we have that are open source, right? So whatever I'll talk about is freely available, everybody can use it, try it out, break it, whatever, right? But before we get to that, I want to give a little recap on business requirements, right? Because it's important when I talk about different MySQL database architectures is that we kind of say like, how do you choose which architecture, right? What is good for whom or what business, right? And the two concepts I suppose most of us are familiar with this is a recovery time objective and recovery point objective. So RTO, recovery time objective is how long does it take to recover from a certain failure? And recovery point objective is how much data are we or can we lose when a failure occurs, right? So that's important. We have this lined out here. So we have time, there's a failure. So the RTO is how long can you afford to be down. And then the RPO is how much of that data will you lose when a certain failure happens. So this is important question to ask your business, your application, it's important to know this before you can go and design and choose a certain database architecture for anything, really. Now, the type of failure is, there's a couple of different types of failure that we have, and to kind of summarize, we have 3, right? We have high availability, and that is within a single kind of region or data center, or however you want to see it, a single server failing. So let's say we want high availability, so we want no data loss, RPO 0, when a single server fails or when a network partition happens, then yeah, that's high availability. Disaster recovery is when a region fails. How long does it, how much time do you have? So what's the RTO for activating another data center? Or like, is it seconds, minutes, hours? And then we have a third kind of failure is human error, like little Bobby tables, like drop database by accident or an application bug. How fast can we recover from that? There's a couple more different types of failures, but yeah, human error, maybe let's say that's where you have to recover from a backup, do point-in-time recovery, something like that. Now, important to know is that when I've done a lot of like consulting and like architecture design, and when I ask the business how, and this is that means I'm talking too much about one slide. When I ask, okay, what's your RTO, RPO? It's always like uptime needs to be 100%, so no RTO 0 almost, RPO 0, no data can be lost. But it's important to look into the context of things, because I think when we design something, we shouldn't. I think it's fair to say we can achieve quite relatively easily an RPO of 0 in high availability within one region. But if you say I want no data loss when a disaster happens, when a whole data center goes out, things are getting a little bit more complicated. And I hope you're not using the internet for doing all your communication, because the internet is not really necessarily a stable environment, right? So it's important, different RTO, RPO, depending on the different type of failure. And of course, it's very important that the MySQL, or we're talking about MySQL here, or the database is just a part of it, right? The network also has to be stable, or the network also has to be designed to sustain that. I have had customers ask, I want no data loss, automatic failover, but my network often goes out. I have, or I'm using the internet for doing wide area network, and I want automatic failover between regions. Well, you're going to have a lot of issues with that. So the network also has to kind of support these claims, right? So these are the concepts, and I'll explain a little bit about the different types of architectures that I kind of recommend, or solutions that we have built in MySQL, and then we'll tie them on RTO, RPO, and what they do, what they not do, right? But before I go that, and that's why I kind of ask these questions, is what is it with the, how do people deploy, and I'm sorry, I'm going to put in the power here because I think this will help. Yep, it won't go out as fast now. So what is important is that we talk about the past and what people are doing. So one person said, I'm using InnoDB cluster, but I feel a lot of people are still using MySQL replication, or maybe Percona XDB cluster or Galera-based solution, which I think is good. But if we talk about the past, and I see many companies, even bigger companies that just deploy MySQL, is a lot of the work that a DBA has to do is all about setting up and automating the database architecture. You have a primary, and maybe you want two secondaries. Well, in the asynchronous world, or in, let's say, more than 5 years ago, like 2016 or before, and you use MySQL, then you would have to set up a primary, then restore a backup of the secondary, configure replication, you have to add a user, you have to kind of set the GTIDs correctly, things like that. So there's a lot of work to be done. And what MySQL did was they gave you technical pieces, like, okay, you have replication, there's a way for you to kind of take a snapshot of the database, there's pieces that we give, but we never fully integrated it. And that's what we have changed since 2016, when our first product, InnoDB Cluster, came out. We started integrating this all to really make it easy, because there's a lot of work DBAs have to do. And for example, my partner is a DBA as well, and a lot of her work that she does, MySQL DBA, I met her at a MySQL conference, by the way. Interestingly. And a lot of the work that they do is automating this setup and making it work and make it their own. But I think a lot of companies, and there are special companies out of there that use MySQL, a lot of companies kind of need to solve the same solution, the same problem. And if we talk about high availability and disaster recovery, it's about RTO, RPO basically. Like, we have some common needs that companies have. There might be different, but they're going to be all in the kind of the same ballpark. I'm not talking about read scale out or any other things here in this slide deck. We're talking about HA and DR specifically here. So in 2016, MySQL released something called MySQL InnoDB Cluster, and that is basically a name. It's just I wouldn't say it's a marketing name, but it's the name of the product, and that is just a set of using a set of different technologies, making something integrated. And by that I mean we have MySQL group replication that is being used, and I'll get into that more. MySQL shell. So you have the MySQL client, but since MySQL 5.7, we also have something called the MySQL shell. And then we have MySQL router, which is kind of a load balancer that can load balance traffic, reads, writes, reads, and so on. So all these products together with the MySQL server as well, like we fully integrate this and we make it very easy to set up an architecture like this, a standardized architecture. One important thing, and there's a lot of features that we added to MySQL 8.0, which went GA 4 years ago, so it's nothing new, is InnoDB clone, which is a way, for example, to, when we add a secondary, in the past you had to provision it, you had to like restore a backup and so on. Now, with InnoDB clone, and you can use the feature by itself, standalone, yourself, if you don't want to use the kind of the integrated solutions that I'll be talking about. Is that it would basically allow an empty server here, and you just say clone from this there, and you do MySQL authentication. MySQL connections are opened. It sends a physical snapshot of the data to the secondary, restarts, and it's up and running, and you can configure replication, and you're up and running. So this is very important because InnoDB cluster and the other solutions I'll talk about, they all are run from MySQL shell, and MySQL shell runs somewhere remote. And it says, okay, you're a cluster, add a member, add another member, and it does everything for you. For router, you just say bootstrap. I want to bootstrap connect to this cluster, and that's all you have to do. So really, it only takes a minute or two to set up an environment like this. Of course, it takes longer if you have 2 terabytes of data to copy. I mean, it's just for an empty setup, it's super, super easy. And otherwise, it's the time it takes to take a snapshot and copy everything over. So what we have here with InnoDB cluster is an RPO of 0, so no data loss in the case of one server failing, FYI. We have 3 nodes here. You can go up to 9 nodes with group replication. No data loss if one of those fails. If more than one fails at the same time, then we do not guarantee no data loss, right? And then the RTO is seconds, and by seconds it's configurable, but the minimum is 5 seconds. So you can have it fail over after 5 seconds of being a node unreachable or network partitioned and so on. I can give a whole hour, multiple hours of talking around this, but I'll try to be brief because there's more to be coming, right? This is only the beginning. So 2016 we released this. We have a lot of users, a lot of our customers are using InnoDB cluster, but then we found some other need, like maybe the user. So the first thought was, okay, we have group replication. I'll get more into detail about group replication, and that's easy to set up, and that's high availability built in. But not everybody needs this. But what if, as a user, you don't need automatic failover? Maybe your network is not as stable, but you still want the same ease of use. Well, that's why we have InnoDB replica set. And what is that? It's basically asynchronous replication. Configuring, so the shell configures everything, does the provisioning, configuring of the replication, adding the users, and the same router integration. So basically the same commands you type, but you just say change cluster into replica set, and you have basically an asynchronous replication setup. You can add as much read replicas or secondaries to this as you want. There's no limit. Question? Or just hair? Okay. Okay. No question? Okay, no problem. So that's 2020. That's when we released this. What we released, was it last year, end of last year, or beginning of this year, is InnoDB cluster set. And this is just a very frequent request that we have from our users. We had InnoDB cluster, which really works fine, but we want disaster recovery. Give us disaster recovery. And So a lot of our users know the time before InnoDB cluster. So what they do is kind of like, okay, let's just set up another InnoDB cluster and manually can configure replication between them. Trust me, that won't work. Why? Because this is an integrated solution. There's a lot of automation happening by shell, and it won't work as you expect it to be because there's like a metadata schema here. The integration will fail, but a lot of users did set it up despite all these drawbacks that they had to take care of. So that's, we took some time. We took quite a lot of time to make it work. We introduced InnoDB cluster set, and basically it's InnoDB cluster, multiple InnoDB clusters. So you can say region in Rome here, and in Brussels, you have a cluster in each. And then asynchronous replication happens from one cluster to the other. And also, like instead of 3 minutes, it takes 5 minutes to set this up. Again, very simple, fully integrated, all automatic. And what we then provide with this is, and of course in replica set, maybe I forgot to mention this, there is data loss because it's asynchronous. Not semi-sync. We're not doing semi-sync here. If you want semi-sync, you're in InnoDB cluster territory. But asynchronous, so data loss is okay. And failover is manual. This is replica set is like a basic version. Why don't we do automatic failover here? Is that the only way to do automatic failover for us is to have a monitoring node make decisions, like Orchestrator or Mysql MHA, or there's been several tools, open source tools available that do this, but we don't want to do that. We do not want to make a monitoring tool that makes decisions and does failover. Why? Because often false positives happen with this monitoring issues. If there's a monitoring host has issues, then it might make the wrong decision and so on. So that's why we have InnoDB cluster, right? It does have the automatic failover. It's basically using a Paxos-based algorithm. It's Paxos, but it's some variant to it. So it does automatic leader election, does the failover. It guarantees that the data is replicated to the majority before it acknowledges. So there's a lot of features built in that make this not need a monitoring host. So this is a lot better solution. So what we did with InnoDB cluster set is that we still have high availability with RPO 0 and RTO of seconds within a region, but then we have a manual failover with some possible data loss. But this is asynchronous replication, so we're talking about if the network bandwidth is not limited and the servers are not overloaded, we're talking about milliseconds data loss usually. It's not going to be a lot of data loss, if any. So this architecture, very important. It might look easy, but we had to do a lot of features for this. One is we have router, and router is everywhere. And router knows about the whole topology. Router knows about it. Router can connect to both topologies depending on the setting that you use. And I'll show you more what the kind of things that we have built in into this. Now the good thing about this is that when you have Rome and Brussels, it's asynchronous, meaning that there's no write performance impact if you write a transaction here. You don't have to have consensus or make sure that another node from the other region has to acknowledge it. There's no issue with that. So you have the same performance with a regular InnoDB cluster, but you have a disaster recovery solution. Yes? Yeah. So why can't we do automatic failover between regions, right? Again, for that we would need a third region, and the one that kind of like witnesses and then makes a decision, right? The kind of the or what is it? The one that can make. Yeah, we could. So there's a couple of ways to implement it. So if you want automatic failover with this, we can't, because we don't have this monitoring host in another region that kind of decides who's the primary. We also, this is group replication stays local. We do not, in group replication, have the concept of an arbitrator at this moment. So something that you're using XDB cluster, the arbitrator is a possibility. But the problem with the arbitrator is that it needs to receive and takes part of every consensus, every transaction. It receives all the data, and that you need a real data center with low latency as well, because it will be impacted. If you want automatic failover, I'll show you later, you just deploy a single InnoDB cluster across multiple 3 regions. Then you'll have automatic failover. And it's, yes, because it's asynchronous, it's not, we need this monitoring host to make that decision. That's why it's not automatic. Did I answer your question? Oh, follow up? Sure. Mm-hmm. It's hard-coded. Is there a reason? There's just concern from engineering that if you do more than 9 nodes, that the communication overhead is too much. So we haven't had users ask for more. And I think if you, like, I don't necessarily see the use case, and maybe we can talk later, of having more than 9 nodes, because usually you want to do this when you have kind of like read scale out or something. You can add asynchronous nodes to a cluster. So, and there's a lot of actually nice features that would help you. And I can show you that later on, that make that possible. Yes, Alan. Sure. No problem. Okay, so in InnoDB cluster, and I think that's my next slide, you can write to all nodes, but there are some limitations. Foreign keys in MySQL are implemented in InnoDB layer, which happens under, like in the storage engine level. So cascading foreign keys are not known to the binary log, which is used to kind of, we don't have the information. The upper levels in MySQL don't have the information available about foreign keys. So cascading foreign keys are a problem, and DDLs are still a problem in multi-primary. You can't drop a column on this node. You can actually, and it will replicate. But if you do a write and use that column, it might break. So there are limitations, and we need to do quite a lot of refactoring in MySQL to actually solve it properly. Yeah. Yes. But note that every member has the full data set and needs to apply every transaction already. So, but I understand, yeah. In cluster set, we even do not allow multi-primary mode. It is a single primary. You cannot enable multi-primary in a cluster set. So we're going to have only one primary, and all the rest is going to be read-only. Even this one is primary, it's going to be read-only. So this is some of the features we implemented. We can, if you do a clean failover here, we guarantee no split brain, because we control that this is constantly read-only. So if we do a failover manually, we make this one read-only, and then we make this one the primary. And we do it in the right order, so we can guarantee like no split brain will happen, which is what some older products kind of did not do very well. They would have the potential for split brain, things like that. Okay, but I'll talk more about InnoDB cluster now, if that's okay. So, InnoDB cluster. As I mentioned, it has 4 different components. So we have MySQL servers, we have group replication, we have router or routers, and then we have MySQL shell. And I'll elaborate on each of them a little bit. And again, I'm staying very high level here, because I have 49 slides, and I'm only at slide 14, and I skipped the first 5. So, but anyway, it can go quickly soon. Okay, so the goals of InnoDB cluster is, we have MySQL, and we have so many products in MySQL, but this is about bringing all those things together, all those features together. We have InnoDB cluster, and that drives the features that we need wherever it is, right? Is it in the router, in the shell, group replication? They drive, okay, this has to work, and they all have to work well together. We integrate it all together, and we test this all together. So we have a QA team that does testing on this environment, right? So it's really good to have, right? Before that, we didn't really have that. We did test replication, we test our technologies, but we never tested the full solution, because it wasn't a product, right? So that's important. Easy to use, so it's very simple to use. I'll show you a little bit how the commands look like. It's JavaScript or Python mode, it's quite simple. And then if we talk about group replication, so what group replication provides you, fault tolerance, it's automatic failover. As Alan asked, we can have active anywhere, but with limits, and I mentioned those limits with foreign keys and DDLs. It's automatic membership, so adding and removing members is automatic. Provisioning happens automatic. A physical snapshot or like an asynchronous recovery, that's all part of this. Shell doesn't do anything there. Shell doesn't copy any data. Shell just initiates, add the member, and all the rest happens automatically. Network partitions, failures, all handled automatically within the bounds, of course, of what type of network partition it is. We have conflict detection resolution, so if you write to multiple at the same time and they conflict somehow, we have basically first committer wins system. So the first one to commit will win and the other one will roll back. That's some part of the protocol. So we prevent data loss in this case, of course. So RPO 0, no data loss when a member fails. So a difference between kind of the Galera-based solutions and group application is in Galera, if you have 3 members, each member has to acknowledge that the transaction was received before the member that executed the transaction will send back to the application, okay, we're good to go, the commit has succeeded. In group replication, the majority is enough. So if this member is kind of slow, the transaction will still continue because there's a majority has received it. So that's a little subtle difference in group replication versus Galera. This also means that if I have one member in another region, you're not going to have that overhead where the consensus will happen local, and in kind of a Galera solution, it has to kind of get an acknowledgement from the other side. So if it's 200 milliseconds, every commit will add 200 milliseconds to it. In group application, not. Sometimes it does, it doesn't. There's like a mode, single primary mode, by the way. There's some, I'm not going to go into detail. I can talk about it more later, where you can enable that. The downside, of course, is with Galera, you know that the other side has received it, but in group application, you're not sure because one node there, majority can be reached here in one region. So if this region dies, there's no guarantee the other side has received everything. But yeah, anyway, I drift off sometimes, sorry. So group replication. So it's total order, so writes are ordered. It's basically one bin log, sequential. That's what ends up with write. Yes, question?
What happens if the majority changes? You have, let's say, 3 nodes here, 2 nodes here, and all of a sudden,
Yeah?
2 nodes crash here.
Yeah.
And the majority has moved, then what happens? The cluster freezes until everything.
The majority will continue. And if the majority does not have the primary, it will get the primary and the write role will enabled. And the minority will go into isolation, like it will wait. It will wait until the network partition is resolved.
Imagine 5 nodes.
Yes.
You have 3 and 2.
3 and 2, yeah.
Okay. So these 2 are delayed.
Yes,
You don't need to apply everything.
correct.
But then in the 3 nodes, 2 fail.
Ah, okay. And the other 2 are isolated as well already?
No, the other 2 are fine.
Okay. Yeah, so let's say, so we have 5, and then the 2 here, 2 of these go away. Then the majority will between those 3, because that's more than 50%. These 2 will isolate themselves, like will go into read-only and not accept any write transaction. If the one isolated was the primary, a new primary will be elected among the majority, one of the majority members. You can configure wait, right? And you can prefer this one if the others are in another location. Okay, that's still the same thing, but when they become the primary, like they were chosen to be the primary, they will you can have a setting that applies the queue before it activates, so it will take a bit longer, and you can also disable that setting. So there's 2 modes, either wait or not wait. Yeah, good. Yeah. Transactions to apply, yes. To queue, to backlog, to apply everything, yes, correct. That's the group consistency, group replication consistency level before on failover. There's like a setting there. Okay, so we have a half an hour left. So group replication, writes are ordered. It's XCOM, which is a kind of a Paxos implementation. It's more based on Paxos Mencius, which is another variant of Paxos. we have configurable consistency guarantees, similar to kind of what Galera has, implemented differently. So you can have eventual consistency, meaning that if you read from a secondary, you're not guaranteed to see the absolute latest. But if you want, you can do it in several ways. You can kind of configure read or write consistency levels depending on your desire. It is using Mysql replication framework. So the same team that develops Mysql replication also develops group replication. It's the same engineers. Well, it's different teams, but they all know about it. And it's using binary logs, relay logs, GTIDs, everything that you use in asynchronous replication, group replication uses as well. It's been GA since 5.7, so 2016, end of 2016, I believe it became GA. Yeah, we support it on all our platforms, so whatever platform we support, group replication is supported as well, including Windows. Not that that matters often, but okay, who's running on Windows? Nobody? Okay, yeah. But we do have it. We do have some users. We actually have some big users using Windows, but yeah, it's important. Okay, so no data loss, RPO 0, I've mentioned that. Split brain is prevented because of the way it works with the quorum calculation. I'm not going to go into much detail. Automatic failover, automatic partition handling. You can do kind of read scale out with it, so you can add more members and you can send read traffic to them, all works. There's automatic handling of replication lag using flow control. There's like 20, 30 settings of it to control that. If a secondary is lagging behind, what do we need to do? The primary will start slowing down the throughput. That's what we can configure. How much it delays, all of this, you can configure that with those flow control settings. The consistency levels I briefly mentioned. You can do active-active, but you kind of need to be careful on the workload, right? The cascading foreign keys are a problem. Doing a lot of DDLs will pose a problem, so that's important. Now, good about this solution is optimistic locking. So the write performance is not too bad. I think we have environments that could do like 20,000 transactions per second. So that's actually write transactions per second. In group replication, I think that's kind of the highest we've seen so far in low latency networks, but it doesn't really matter. So we've seen that, so that's good. And the added latency, because of the way it is implemented, we only add one round trip. It's not like a two-phase commit that we need to do. We don't need to like prepare all nodes. Okay, everybody prepared, commit. So that's two messages we have to send back and forth to the nodes. This is not done like that. It's basically you send the traffic and the nodes say, I confirm that I've received it. So that's one round trip added. And that is enough for group replication to know, okay, the majority has received it, I can continue. We then have a certification that happens to guarantee that there's no conflict. So that happens without communication between nodes. Also, because every member has the full data set, during a transaction, no extra communication happens. It's only at commit of the transaction that any network communication is happening. So you're staying local within a transaction, you'll get InnoDB performance just like you're used to with a single or asynchronous replication. Okay, so briefly a slide on MySQL router. This is our integrated routing solution. At this moment, there's actually new features that we've released. We released some features last quarter. It's basically you configure your application to connect to the router, and the router will figure out where to go. And at this moment, the router is a layer 4 load balancer, so it does not do transparent read-write splitting. There is a port for reads, and there's a port for writes. So be aware of that. And router will know, reads, I need to use the secondaries. Writes, I need to go to the primary. So that's based on port. It also has like TLS offload, so you can do the TLS SSL connections happen locally if you install router on the application servers, and then the server we have connection reuse even now recently, where the connections remain open and then we just reuse another connection. Authentication never happens by router. Router always proxies the authentication to the server. So if you're familiar with proxy SQL does the authentication. Your user management has to happen in proxy SQL. With router, no, this is as lightweight as it can get. Just very small binary. It will proxy the authentication to a server that does the authentication, sends it back, and that's it. It will never authenticate. But we have this kind of connection reuse. So we do a local SSL, because SSL is a lot of back and forth, so that adds latency. You can do that locally very fast, and then we reuse another kind of open SSL connection that we already have. And that way you can kind of reduce latency. Router, we have users that have hundreds of routers per group replication cluster or per InnoDB cluster. Why is that? Well, we have like features. So MySQL has the MySQL port 3306, that's the MySQL protocol, but we also have the X protocol on port 33060. And in one of the features of the X protocol, apart from doc store and that's our kind of our NoSQL API and a regular SQL API, is also notices. And what we have there is that when the topology changes, it sends a notification to all the routers who have a connection open, and they don't have to pull every half a second for the status. They don't have to monitor the status of the group. They'll be notified. So that's why we support like hundreds of routers on a single group. We don't need to do health checking that often because it would overload the database servers. So there's like a lot of little features there. I wish our documentation was a little bit better, so I hope we can work on that, because router has quite a lot of features. But I think we need more how-tos written. So I think I'll give a presentation soon at another conference, I think Cloud World, about all these use cases, all the things that router can do. Also, router works for replica set, cluster, and then cluster set. It doesn't matter, it's the same router. So that's also very easy. And then we have SHell. So SHell also was released in 5.7. So you have JavaScript, Python, and SQL. So the default when you log in, it's JavaScript, and you can write your own JavaScript plugins. You can actually write plugins that do all kinds of things. So very, very easy to use. It does this doc store, our document store. It supports, just like our connectors do as well. So it does both protocols, the MySQL protocol and the X protocol. And maybe I'll have an example here of how does it look like. I don't have a demo here today because I still have 25 minutes, but that's not enough to do a demo. If I wanted to give all the other 20-something slides. So here's how you connect. You start shell, and it's in JavaScript mode. You connect to user admin on MySQL 1, and you say, I want a cluster object, and that's dba.createCluster. That's how you create a cluster, a one-node cluster. By default, it will error out because the configuration isn't applied yet. So you're connected remotely on a server, and it will say, the setting, this binary log setting is not good, or this or that, or server ID isn't set yet. Well, DBA configure instance on admin at MySQL 2 or 1, so let's say we want to add member 2, it will configure it. It will say, okay, all these settings we need to change. Do you want me to apply that? Yes. Do you want me to restart the database if it's not dynamic? Yes. So MySQL 8, you can change set persist only. There's a restart as a command, so you can restart the database. So we can do everything we can do remotely from a machine. So if you have containers, which is kind of common nowadays, you can just connect to the MySQL. You don't have to get a shell somewhere on a container to execute commands. Everything happens remotely over that MySQL connections. And you can configure it, set any variable, restart, and so on. It will do that all for you. Let's say you want to add the instance. So we have the cluster object that we created here, and it's like a one-node cluster. And we do cluster.add instance MySQL 2. Ta-da! It will say, okay, I have no data. You want me to provision it? I can do either binary logs or I need to clone it. What do you want? If it knows that there's not enough binary logs available, it will say you need to clone it. So you can do clone, it does all the cloning for you, and it adds the member to the cluster. If you then want to add MySQL 3, it's the same command, add instance MySQL 3. But if you then want to configure a router, this is the only thing you need to do. MySQL router, so on the wherever you want to install router, as user MySQL router, that's the shell, that's the kind of Linux or Unix user you want to run as, bootstrap. That's all you need to do. Well, you say the host name, right? MySQL 1, for example. And then you start it, and that's all it needs to do. When it bootstraps, it connects. There's a metadata schema. It knows based on the metadata schema we should have MySQL 1, MySQL 2. And router generates a config and then updates kind of a state file as it runs. It monitors that metadata to see if there's any new members whatsoever, what's the status of these members. Then you can get the cluster status. So it's one of the commands, there's many, and then it gives you a JSON output with the status. So we have the primary as MySQL 1, it's in read-write MySQL 1, and then we have two read-only members here, MySQL 2 and MySQL 3. You can do like extended status, you can remove instances, there's all kind of operations that you can do. But that's basically how you deploy a cluster. And if you want to deploy a cluster set, which I'll talk about later, it's just basically cluster.create cluster set, another member. And there you have it, you have another cluster. So it's almost the same command to run. So replica set, one slide only on that. It's less frequently used, but still we have users for it. Is same integration, but it's asynchronous. It still does the cloning and the user handling and the configuring of replication, and it's manual failover, but also SHell provides all the functionalities to do a manual failover. Even in cluster, you can say set primary, you can change the primary. Here you can also say set primary. Oh, I want this to be the primary because I need to do some maintenance here. Sure, you can do that. Shell will automate all this for you. If you want to make it automatic, it's up to your responsibility. You can just write a wrapper that does health checking and then does set primary or force primary. So we have set primary, which is a switch over, like a clean changing of primary, and then we have force primary, which is a failover that we do, which of course can create some split brain, but it will tell you all that, and then you have the opportunity to kind of do a stone it or whatever you want to integrate on how you want to use this. Okay, any questions so far? Now we go to cluster set. I'm just talking all the time and nobody else is, so. I see people nodding, so that's good. A few people are falling asleep, but that's also fine, you know. No questions? Now, this is our one of kind of the latest development, right? Is cluster set. So we talked about InnoDB cluster. We have cluster set now. So the same exact ease of use as with the commands, how to set it up and what so on. You can have one cluster, but you can also have multiple clusters. So let's say the primary cluster is in Rome. We have one in Brussels. Well, you can have one in Lisbon. You can have as many as you want. There's no limit, actually. We didn't define a limit. Like there's 9 nodes per InnoDB cluster. There's no limit on the amount of cluster set clusters, but I think there's be a practical limit or some kind, right? You also are not required to have every cluster to have 3 nodes. You can add a third data center with a single node if you want. You won't have high availability in Lisbon, but you can if you want. Nobody's gonna prevent it. It just works. Okay, simple. Here, let's say we have this environment. This is, okay, a little bit of route. Oh, questions. Sure, ask the question first. I'll explain it. I have a couple slides, but I'll explain it here already because I kind of have to put some context on that. So let's say we have 2 data centers, so Rome and Brussels. The primary is in Rome. We have 4 routers, 2 in each. We have a target mode. It's a bit hard to see. I need to change the font here. You have different target modes. And important to know, and it's weird nobody has asked yet because I get this question a lot. Can I do bidirectional between clusters and can I do it active between clusters? The answer is no. Why? It's asynchronous. We cannot guarantee that there's not going to be any conflicts. So we are not going to make a product that is going to make you lose data or have a split brain. So either we will have a fully supported solution that will guarantee that there's no split brain, or just go and deploy your own group replication and whatever you want to do, but not in our solution, right? This is, you're laughing, but a lot of people are doing this, right? So many people, and I have to talk a lot of people out of this. Yes, and you too, right? At your work. Okay, router knows. So the default way router works is target primary, which means it will send writes, which is red, and then reads in green, it will send it to the primary cluster. But you can also change the target mode. This one is in target mode Brussels. This one is in target mode Rome, which means that, well, I made it a reporting application because it only does reads. But if you send writes to this one, writes will go to this one because the primary is in the primary cluster. So Rome is the primary cluster. It has the read-write node here. In target mode Rome, if we send it right here, it will go here and it will send it here. Now, it's a little bit of a decision we had to make. If this one is in target Brussels, if a write happens here, the write will not continue because there's no writer here. This is the current situation. You cannot say target Brussels but send the writes here. We can add that to the feature of the code, but it would delay us the release of this product. So we need to release this as is and not delay it. And one of the things important for this is this router is so lightweight. Just run a router with a read-only and run another router with a read-write mode, and then you can have it as target primary, and then send your write traffic to that one. And that one will follow the primary, and then this one in target Brussels will send the reads always local. So it's because the router is kind of lightweight. Now this router will know within seconds that a machine has shifted, right? Like, let's say this became the primary, router will detect it within seconds. What else is important here? Oh, you can change target modes, and the features that we're doing now to router. Router, as I mentioned, is lightweight. We do not want to do authentication there. We do not want to we want to keep it lightweight. And the way you configure router for these modes and other settings that we're having is you do it through shell. You just say, this router needs to change its target mode right now. What happens is shell updates the metadata here, router will know, oh, my target mode has changed, and it will change the way it behaves. So what we avoid trying to do is, we don't want you to have to change a config here. We also have a REST API to check the health status of every router, but knowing that routers can be deployed everywhere, we don't want shell to have to connect and send an API request. No, we can all do this centralized because there's a database. Hey, look, we can use the database. It's highly available. The data is there. So we use this. We heavily rely on this to just update its config, and router just learns about the changes. It's a very neat, small, simple design, but it works. So it makes it really, really possible and flexible. Oh, 2 questions. Web. Yes. This is fully using GTIDs. Oh, good question. So the question is, what about GTIDs? So GTIDs, Global Transaction IDs, I think was introduced in Mysql 5.6, or is it 5.7? I don't know. It used to be that if you configure replication, you had to configure binlog file position. Like you change master, it was then, now it's change replication source, is a new syntax. It says, okay, this is the file, this is the position. The problem is, if you want this machine to replicate from this one, the binary log file and position is different than this one. And with GTIDs, global transaction IDs, there's a way to say, just replicate from this one. You know what you've applied already. It's like, just GTID said I have, I don't have this, give me whatever I don't have yet. So this heavily relies on it. Group replication uses 1 GTID per cluster. So we have 2 GTIDs here. To be more precise, there are 2 GTIDs per cluster. There's a management one that we had to implement. Yeah, it's an implementation detail. We had to add some features to make this work. We had to add another kind of a management GTID. So you'll regularly see 4 GTIDs if you check the GTID set. Yes. Yeah. It's the view change UUID. Group replication view change UUID. And the reason why is that if a primary switches here, like something happens or you add a member, a UUID is sent with the change, the new topology. But in a split brain situation, you create GTID inconsistencies between them. So that's why we put it on a different UUID so that we can reassemble it and we know it's a management. We can ignore the management GTID events. Yeah, yeah. Okay. Sure.
Consider the impact to speed performance if you move the authentication authorization to the router, then you don't have that whole round trip to the data.
Yeah. Yeah, we don't, because then we need to have users and passwords here in the router, and we don't want to do that. Yeah, and it's so SSL happens local. We can have that, but then the authentication is just the authentication string, and yeah.
So why did you not want to do it there? Like I realize you wanted it to be lightweight, but like
Security. Yeah. You have to start replicating users. Yeah. Yeah. Well, they could sync it, right? The routers could fetch. Yeah. Yeah, and we also have this audit logging that we might want to do as users. We have like in our enterprise version an audit log, so we want to know who authenticated. So we want to keep control here. And the overhead that we've seen, we don't have users complain about that about that specifically. We're also adding kind of like connection reuse to the mix. It's actually the connections are reused, right? So the overhead becomes less because we don't have to open a new connection. So less overhead.
is there a small limit on the connection pool?
You can configure it. You can configure the pool how you want it. Yes. Yeah. Whatever you want. Yeah. There's no limit. Yes, you had a. Mm-hmm. Yes, you can connect the replica through a router. Yes, that works. Yeah, that works. But we added features that we don't need to do that. And I can show that. I can show that in the next couple of slides, yes. Whew, 3-4 questions. Yes, go ahead. Yes.
How long does the connection stay alive, and how do you know if that connection is still viable?
Yeah, so there's a timeout configuration for that one. There's a limit on how many you want, and it's also not in total how many, it's actually per user and connection capabilities, because remember the authentication, we don't want different users to use the same kind of connections. So there's a little bit of difficulty around that. And then what was the last? Yeah.
You've answered it, which is that
Okay.
you're using parameters time to live, and you're using number of total users
Yes.
of the connection, and then it renews once it hits
Correct.
either
Yeah. And it's just, I think the configuration is if you have that many idle, start closing them. So keep that many idle as you want.
So it's pretty similar to other types of
Yes.
connections.
Yes, but router by itself cannot open connections because it doesn't know how to authenticate. So it needs a user originally to open an original one, yeah. And there's a bit of a trick. We need to keep state of the connection tracking, session tracking. Like there's a lot of state we have to manage and make sure that they are compatible for the different users. So things get quite complex. Yes, question. The router instance, or new connections have to be opened. So the application then authenticates again, and the router is basically a man in the middle. That's what it does. It kind of, yeah, it knows some things, but it doesn't know the clear text password, but it can use whatever hashes were there to kind of, forward it at least. But it doesn't have access to the actual password. Bootstrap once. Yeah, question.
This implementation here, I can see it's some kind of availability.
Yeah.
What about a disaster recovery architecture where you have one of these things, and one instance is on-prem and the other somewhere on the cloud?
Mm-hmm.
Is that a use case comparison?
I'll show you. That's what the scenarios. I'll show you the scenario. After these slides, I have some scenarios. What if a region dies? What to do? I'll show you.
In this diagram, we have this from reversal, one of the indication is when the target is printing here, the red line, right?
Yeah.
So when I bootstrap it, how do I bootstrap?
You bootstrap to any of them. It doesn't matter because router figures it out what to do. Router will know, oh, bootstrap to this one, it will see the metadata, it will know that this one is the primary, and it will register through here, and it will replicate to everywhere, and that's it, yeah. Yeah, you don't have to know the primary. That's easier for automation. When you automate this, just give it one of them, and it's enough. Sure.
Related question on the route. Is there a number of connections, the total number of connections limit to it? You mentioned that the router
No.
can be lightweight,
No.
but it can handle as many as the underlying OS can handle?
Yes, I think we switched to, what is it, event-based. We don't do threads for each connection anymore, so that's better. I don't, the scalability kind of depends on router, but it does seem like from what our users say, they haven't raised any issues on that yet, yeah. Anyway, I have a couple more minutes and 19 slides, so. Yes, correct. You can actually switch if you want. Okay, let's show some use cases and scenarios, right? Let's get down to it. I have 7 minutes. Okay, good. Let's say we want to switch the primary cluster. So this is manual. So changing a cluster, this is a clean operations that I'm going to show you. You have 2 regions. You just want this one to become primary because the workload shifts there, or you want to do some maintenance, whatever, right? It is one command, set primary cluster, and you just say, change the cluster to here. So in purple is everything we do, right? Replication will be reconfigured. This one will become the primary, and this one will become the secondary. So router will also know, oh, I have to connect here now, and it will start connecting here. Target primary, writes come here, writes suddenly move there. These writes will also move to that one. So this one command, and it will do automation, all the work necessary for you to do this. A second, or yeah, it's very fast. There what? Well, yeah, what we need to do is we need to put the primary, all primary read-only, all connections that are ongoing need to commit or roll back. So it kind of depends on your workload, yes. Yeah. Okay. Then router, I think I mentioned most things already, so I'm going to skip some things. Then, because I've mentioned it's the target modes, I've mentioned these things. So scenarios, as the person mentioned, what if something happens? Scenario number 1, the primary dies. Not the whole cluster, just the primary and the read-write member. The primary of the primary cluster. The primary member of the primary cluster dies. What happens is, InnoDB cluster or group application will just elect a new primary. This one will become the primary, and automatically the async replication will also move to the new primary. So that's fully automatic. So we had to add some features to asynchronous replication to make this all happen. You can actually do this all yourself. If you just use regular asynchronous replication in MySQL 8, you have the concept of not change replication source to master host. You can you give a list of it even. And even the replication knows about the group. So it kind of knows about the whole cluster. Let's say this one dies. The replica cluster primary, which is read-only, but is one receiving the transactions. If this one dies, replication will be restarted and will continue here. Fully automatic, so you don't have to do anything. So these are kind of the common cases, right? If you do the clean switch, it also does it automatically. Now, that's what you mentioned, the use case. Let's say it's partitioned. It didn't go on fire, it didn't lose connectivity. We have 2 clusters, right? This is asynchronous. So our application is stuck. Nobody can access this application. So what do you want to do first is fencing. You want to fence it. You can actually fence it. We have features that we added to fence it. You can say fence writes. So we know, because we don't want to, writes can still happen to this one. It's the old primary. So we need to reduce split brain as much as we can. So you can do fence writes, and it will put the whole cluster in read only. Or shut it all down. You can kind of choose what you want. Assuming you can get to it, yes. Correct. If you can't get to it, maybe power went out. That's a good thing, right? But if you cannot get to it, there should be ways to get to that isolated one, right?
Just maybe not immediately.
Yes, correct. But yeah, but maybe you can access through some console, some other way, or there's another internet line to get in. Yes, correct. Yeah. You put the whole cluster to read only, yes, correct. Yeah. Not cluster set, correct. Yeah. You do it on a cluster, yeah, yeah. Well, this one is not, this one is still a replica. At this point, it's still read-only. So you fence first, if you can fence it. If you don't have to fence it, but it's up to you. We do recommend it, of course. So suddenly everything now is read-only. What you now want to do is you want to make it read-write. So you do force, so not set primary cluster, you force primary cluster it. And you say, you make this one read-write. So router will notice, oh, I have a new primary here, and it will start sending write traffic here. Now, because we fenced, if the application still, so cron job might be running and might be doing some updates on the database, that without fencing, that will still happen here, and we have a split brain situation. So with the fencing, we reduce that possibility. Now, what happens if the network partition goes away and it recovers? These routers will notice that there's a new primary. So in the metadata, it knows that this one should be the primary, not this one anymore, and they will automatically send all the traffic there.
What happens if on the first cluster there was a primary, we weren't able to fence it, but we did the force
Yes?
set master?
Then is this?
Do the other routers know that somebody was done a force set master?
Yes, it will know it as soon as it can connect to that cluster again. Yes. So here it's read write, and that one will be read write. But if we switch, yeah, it knows. Correct. And I have 1 minute left. A lot of questions. Now to summarize, so you can see the slides online. To decide when to use what, right? If it's HA, we have InnoDB cluster, no data loss. RTO, the time to recover is seconds. With replica set, there is possibility for data loss. RPO is minutes. With multi-region disaster recovery, we've showed you this, right? InnoDB cluster set, which means RPO is 0, RTO is seconds within the region. Write performance is great because it's asynchronous. The RTO is higher on disaster recovery because you have to manually fail over. Now, one thing that I haven't talked about is that you could also deploy a single cluster across 3 regions, and you'll have full automatic failover. You'll have no data loss when a region fails. You can add 2 nodes on each, fine, because then you have some kind of local high availability. So this is also something possible, but you need very good network for that, and your write performance will be affected by the latency of this. So this is another one. This is, well, synchronous, none of them are considered synchronous, right? It's yeah, or virtually synchronous, whatever concept you want to call it. But you can get synchronous if you want, yes. Anyway, that's it. There's some links. Everything is available, open source, use it. So, and that's kind of the direction and a lot of effort that we put in. So if you have any more questions, that I have to stop because the next talk is? The slides I will put online. Slide share or on Oracle, Tina will add it. And I'll upload them now, today, yeah. Okay, thank you. Sorry, Dave. Ooh. Sorry? I have to say it again, and then questions start. Yeah, well, I'm used to having hundreds of questions. I like it. We drift off all the time, right? I like to have questions because you were falling asleep, huh?
I was listening.
I know. There's more people. It keeps people more awake, huh? Yes. Wake up. I know, there's a lot. But it's the thing, we don't have a lot of, like, we have a lot of customers using it. We have, like, people here, when I go to conferences and community kind of, it's less, we see less of it. It's odd. People are stuck on what they know. That's what it is.
That's the case too. I mean, I haven't looked at this stuff from you guys in 5 years, something
Okay.
like that.
Yeah.
You know, so it's interesting to see all the changes. It's also really interesting to see the kind of like design patterns that are adopted by not just this product, but
Yeah, make it easy.
I really like the fact that the primary number is the read write and nothing else, because
That's a Galera who just commit so easily. You can select the primary and the other ones in read only if they want.
right.
Because it really makes it easier. Because Galera, that's a bit of a downside, I think, sometimes. But let's give it to Dave.
Sorry I was late, Dave.
No problem.
Oh God, they give the presenter more than 3 dongles to deal with. See if this works. There we go. How's that level for the back? Okay. And I just lost my... Okay, folks, thanks for coming out to the last talk of the MySQL track for this year. SCaLE is one of our favorite shows. And this talk is called A Survey of MySQL Index Types. My name is Dave Stokes. I'm a technology evangelist in Percona. Been there since February. For those of you who are... that's a slash model Gibson Les Paul at the Gibson shop in downtown Nashville. Well, it's very rarely I get to touch an $8,000 guitar, but I can tell you more about that later. Anyway, before this gay guy's working for MySQL on the community team for almost a dozen years. So today we're talking about indexes, and without an index, the entire table or file has to be read. Data may not be ordered. It's time-consuming. And you can tell by this gentleman here looking through this tome that if he's looking for one thing, it's going to take him a while to get to it. So I'm talking today about InnoDB indexes. MySQL has other storage engines that I'll be nice and say they're forsaken by Oracle, but InnoDB is a superior storage engine. So with an index, you gain the ability to go to a specific location that has the information you want. And that way it's faster. You don't have to read all the previous stuff. You go right to the entry you want. So if you want to know something about Cardinal Adrian, you just go to page 63 in this book. So I have to know absolutely nothing about Cardinal Adrian, and I like it that way. So MySQL uses something called a clustered index, and that is built on top of a B tree. Now, for those of you who've been playing around with MySQL for a while, you're going to have to forgive me. I like to give simple illustrations because I get a lot of novices in my talks, and this is one of the talks I've been giving lately. So, as you can see, it's kind of a tree with the trunk at the top and the branches and the leaves at the bottom. And it's very nice that everything's kind of split up. As you can see, the second level, we have 1 to 47, 48 to 1001. On the intermediate nodes, the root node is everything. Intermediate nodes, everything's been split in two. And below that, things have been divvied up again. So
this is called a B+ tree, and it's very easy to search for one record or a range. So if you want to find record 22, you have that nice little red path there. If you're looking for a range, you're looking for records between number 17 and 42, it can very easily go out and grab those. It doesn't have to read the stuff in the 1 to 15 or the 48 to 1,000. And with MySQL, the records are stored by primary key. And if you do not pick a primary key for your data, MySQL will pick one for you. And like everything else in life, if it's picked for you by something else, it's not going to make you happy. So this is some dummy data, where on the left we have the primary keys. So the top record, we have the primary key for record 001 and the data for 001. Now, people come back to me and say, well, I don't want to index by a primary key. I have these other things that I want to group together. Well, that's a consideration for something called a secondary index. And the idea is that you want to have a unique primary key that's not nullable for each row. Secondary keys are non-primary keys, and they are used to access records in other tables. Best type is not nullable. By the way, if you saw Bruce Momgen's talk yesterday on nulls, and you can explain it to anyone else, including Bruce Momgen, what exactly a null is, you are ahead of the rest of us. Keys are what make up an index. And big hint is avoid nulls in indexes. And please do not use GUIDs as primary keys. We'll talk about why later. They might make an okay secondary index. So creating indexes are very easy. Now, whenever you create an index, remember they take up space in memory and on disk, and they add overhead. So every time you do an insert, update, or delete, that index needs to be maintained. So here's a quick demo. We're going to create a schema called PL demo. We're going to use that demo. We're going to create a table, and that table is called EX1. It has 3 columns in it, one called MyID. It's a type serial primary key. Second column is C1, third column is called C2, and they're both integers. Now, if we do a show create table on this, this might be hard to read in the back. This is not the way I recommend creating keys, by the way. So we have our C1 and C2, both integers, and you notice that MyID is defined as a big integer, unsigned, not null, auto increment. The reason you want unsigned is it gives you a wider range of numbers. There's not negative numbers. And not null, once again, you don't want nulls in there. And auto increment means every time you insert a record, the server will automatically increase that number by 1 when it puts the record into the table. Here's a little bit better look at that. Now, some things mentioned is you go unsigned, you get a range of 0 to 2 to the 63rd, which is usually enough for most people. Not nullable means there's no null values in a column. Null arithmetic is kind of interesting, and it's easier to make sure that you have a one-to-one record that's easily identifiable in your indexes. Now, here's the contention. We have our primary key, which is the auto-incremented key. And we also have a unique key, because I used the keyword serial when it was defined. In Postgres, you'll see serial used a lot more often than you do in the MySQL world. Can anyone tell me what the problem with this is? We have 2 indexes on the same table, which means we insert one record, we have to do 2 inserts into the index. Not what you want. What you want are auto increment records, and that will make sure the things are unique. So skip the unique key, that's the default was serial, or you can do that. So my recommendation for all your primary keys, and once again, you want a primary key, is use an int or a big int, unsigned, not null, auto increment. What if you want to search the record by the first numbers in the customer ID? So like a VIN number on your car, the first couple digits tell you who the manufacturer are. We're going to, let me create a dummy table here. New table. And we're going to put in some random numbers for the last two columns. And when we do run explain on a query where we're looking for any records where the ID equals 7, this is the output from explain. Explain is how you see what the query plan is. You notice that the good news is we have two possible indexes, and it's going to use the primary by default, and we are going to pull back one row, which is what we want. Oops. Now we're going to use the bad keys from the previous example to show some multiple possible keys. So now for comparison, let's create another table. It looks pretty much the same. The only difference is that we have the int unsigned, not null. But this case, we don't have an index on there. So when we go to look for record number 7, we have to do a table scan. The table scan means we have to read the first record to the last record to find the one we want. Now, if we add an index in there, we only have to get one record. And notice that in both cases, you get one row, but the cost goes from 1025 down to 0. And it actually gets the information from the index. It doesn't have to actually go out and read the data. Now, if you do format equals JSON, you get a little more information of what goes on. The query without the index, it has to do a whole bunch of reading, 9 versus 0, an evaluation cost of 1.1, and a prefix cost, which I won't go into, that's 10.25 versus 10.0. With explain, you can see what the various costs are to doing your query, and you usually want this lowest cost query. So, yes, sir. Well, when you do the primary key, it does. But one of my demonstration tables did not have an index. So, indexes work. Can we just index everything in the table? Well, you can, but it's going to be very slow. It's going to soak up a lot of memory, and I'll give some more details later on that. So, what can you index? Well, as I said, you can index everything. You don't want to do that, but there's a whole lot of things you can index. By the way, you can create indexes with the create index command or use the alter table command. So I'm going to have a made-up demo here. I don't know if you made it down the Bracona booth yet to see the Yonk box. This is a box where you can twist some dials and flip some switches, and it actually changes the load on some servers running Postgres and MySQL. And you can see on the PMM, Bracona Monitoring Management display, what is affected. You can get rid of an index, you can change the running load, and I'm missing some slides. Oh, here we go. So this is a Yonk box down here. I think this is the one downstairs. By moving these dials or flipping switches, it affects the display for the database management software. So in this example, we have a fake company called Yonkbox LLC, and this is a better look at the various switches and buttons on a previous edition of it. So for our business, we're going to create a customer order table, and we're going to track everything by an order ID that we're going to call order ID, really creative there, customer ID, order date, estimated delivery date, item number, and an ID number for the worker that it's assigned to. Now, this was done because we know each Yonk box has a serial number. They're not made till a customer makes an order when assigned to a customer. A date when it's ordered, an estimated delivery date, and an item number, which in this case could be the deluxe model, the platinum edition, and hopefully maybe when we start this we know a worker is going to be assigned to. So we have this information that, in this example, I'll pull out of the air, but this, when you're creating a project, you're going to have similar information for what you're going to need to store in a table. So if you want to quickly search by customer ID, there's a way to do that. And this is one of the things we're, in parentheses, you'll see this is why you need to know how you're going to use your data when you're designing your tables. If you're doing time series data versus transactions, you're going to lay out your data a little differently. So on our little table, we're going to create an index, and we're going to call it customer order customer index. You can come up with your own schema for naming things. What I like to do is have the table name and the column name with IDX for the index number, or the index name. And then I say that I'm going to do this on the customer orders table customer ID column. Well, let's say, we'll come back to the Yonk box in just a minute. MySQL also has the ability to index geometrical information. So if you want to write your own version of Google Maps, you can do that. This is a lot tougher than it looks, even if you have a lot of geometry behind you. But MySQL has spatial indexes. What if you want to search for keywords in your data? So we're going to change our customer order table. We're going to add a column called description. It's a varchar 500. And we're going to add a full text index that we're going to call description index on the description column. Now, here we've made two modifications to a table. We've added the description column and then the full text on it. And we can use this with the match keyword. So we're going to match the description column against the word gold. And we just happen to have one record in here with that. So we have the regular, we have partials, all that. Functional indexes. This is something that came out a while ago with MySQL. In the past, if you were doing a comparison like greater than October 31st, 2021, it couldn't use an index because it had to do a whole bunch of machinations to put the data into something you can check. With a functional index, what we're doing is we're doing a computation on one of the fields. In this example, we're taking the month out of the estimated delivery column and creating an index just on that. So if we want to run a report very quickly on who's getting their Yonk box in the month of August, this type of index speeds that up. And you can see that the explain plan tells us that we did an index lookup using our new index. Now, if we want to look at another functional index, let's say we have a 50% markup on the cost of the product before we can sell it to give the cost of the box. The great thing about functional indexes is that we're doing a computation, and whatever we want it to be, we can put it in there, and it's a valid index. Now, if we're searching using on this new index we're just creating there, you see that we get an index range scan. So instead of just going right to the index to find a record we want, it's going to be reading through a range of items in that index. Multi-value indexes. The gentleman who's speaking before me, Kenny, was kind of the father of this at MySQL. A multi-valued index is a secondary index defined on a JSON column made up of an array of values. MySQL does not have an array data type. JSON has an array. So people started using the JSON data type as an array data type. The only trouble with that is previously you could have one index entry per row. But in this case we have multiple entries on the row, and we just can't have one index entry. So multi-value indexes let you get past that. So here I have some dummy data called customers, and you'll notice in the info column we have zip codes. Your customer has multiple plants that we're shipping stuff to. So if I want to find out where the customers have a zip code of 12345, and we're going to use the member of operator to be able to come back and tell us who has that. Now, if you look at the create table, it's actually casting the info from the zip code as an unsigned array. So it does a little magic behind the scenes. Multi-column indexes. Your indexes don't have to be just one column, they can be many columns. Now, the old rule used to be put the highest cardinality or the rarest in the leftmost column and work down. If you're really interested to see me later or see me tomorrow in the booth, I can show you where you don't always need to do that. Over the past couple of years, MySQL has gotten really sharp at pushing this down to the storage engine to pull this back, so you don't always have to do that. So we're going to create another table called X, 3 columns. We're putting in some dummy data, and we're going to create an index on the 3 columns that we have, C1, C2, and C3. So if we're looking for a record where C1 is equal to 1, C2 is equal to 2, and C3 is equal to 3, it's of course going to use that index for us. Now, if I'm not looking for all that columns, what's interesting is it still uses that index. Now we're using the first 2, which kind of follows the general rule, and it's going to use that index to find what we want. Now, let's change it and look for the first and third columns. Now, traditionally in MySQL, because we're using the first and third columns, it would not use that index because it's supposed to work most exclusive, next most exclusive, and so on. But you notice in this case, where we're looking for C1 equals 1 and C3 equals 3, it's still using our index. This is one of the things, I'm writing a book on indexes, and it's like, hey, this isn't following the rules that I learned. Okay, foreign keys. Anthony, you've been around MySQL, probably the only person around it longer than I have. What's the general rule on foreign keys? Well, the idea is you have a key in one table that points to a record in another table. And for a long time, people didn't like MySQL foreign keys because they didn't work very well. That reputation has held up for a lot of folks. Other folks use them without problems. This is something to test and see if you like. If you like them, fine. If you have problems with them, do all the relationship management yourself. So here we're going to create a table called X, insert some values, create an index on those values, and we're going to use the tree format on the explain pan. And we're looking for, that slide is out of order, I'm sorry. This one should have been 2 up. So now we're looking at the second and third column, where C2 is equal to 2 and C3 is equal to 3. For some reason, in this case, it wants to do a table scan. It can't figure out where to go. It doesn't have the first column, so it doesn't know how to hook that into the index. Now, let's change our data a little bit. And no, we're actually not changing the index. Yeah. Mm-hmm. Well, I keep wondering why we're not doing bitmap scans or like Postgres. Now, sometimes you get lucky, and in this example, we're doing a select star from X where C2 equals 2 and C3 equals 3. And we're ending up with a table scan, which is expensive. Now, if we come back here and go back to where we do the direct match of C1 equals 1, C2 equals 2, and we've done our index X on the 3 columns, covering index lookup. That means that the server does not have to dig into the data to get the response to the data or to your query. It's going to give everything off the index. Here we go. My slides are out of order. I'm not sure why. I'll have to update that. This is one where I was talking about foreign keys. I'm not sure how these got scrambled. Okay, foreign keys. We have 2 tables. Parent, and it has an ID and the primary key is ID. We have a child table, and we're going to say we're going to have an index called parent ID that we're going to call, pointing to here. Now the foreign key is going to actually reference the parent ID field in the other table. So child points to the table, the parent table. And we're also saying that whenever you get rid of a parent record, come through and delete the child references. There can be multiple child references. Okay, hash joins. This came about 2 years ago in MySQL. And if you're doing equijoins, it's much faster than additional nested loop join. Right now, what MySQL will do is if you're joining 2 tables, it will take the smaller one, read the first line, and then a loop to the second one, pull in that data, go to the second line, and go back and forth. Now, if you're doing an equijoin, and what I mean by equijoin is you have columns that you're using an equation symbol with, it will run out and do a hash join. Hash joins are great because it basically takes everything from one table, puts it in memory, and then reaches out to the secondary table. Instead of doing one at a time, it tries to do them all at once. Okay, invisible indexes. MySQL supports invisible indexes for 4 years now. The invisible index is not seen by the query optimizer. It's not per session, it's for the entire machine. And this feature can apply to indexes other than primary keys. When you do this on a primary key, watch out. And it's much easier than removing an index for testing and then having to rebuild. So we're going to create a table. Actually, we're using the MySQL world database where there's a table that has a bunch of city information. And if we're looking for the records where the district is equal to Texas, and there's no index there, it has to do a table scan, and the cost is $442.24. Now, if we alter the table and add an indirect index on the district, and we run the same query, it drops from 442 down to 9.10. In this case, it has to read 4,188 rows. This one only has to read 26 rows, much less work. Now, if we alter the table to make that index invisible, we go back to our old number. Now, in the old days, what would happen is you'd have an index that you didn't think was doing much, you blow it away, and about 3 minutes later, someone calls you on the phone saying, hey, my query's suddenly dragging, what's going on? And then you have to rebuild that index, which can take seconds, minutes, hours, longer. Histograms. This is something that also came out with 8.0 that's an option instead of running indexes. Instead of indexes, histograms let you give more information to the optimizer without the overhead of an index. The only trouble is it's for data that doesn't churn, doesn't have a lot of changes to it. The more static, the better. And the optimizer by default assumes an even distribution of a data within a column. Those of you who do any sort of analysis will find out and know that that is a very rare situation. So let's create a table called H1, and we're going to have an ID and a column called X. And into X, we put in the values of 1, 1, 2, 2s, 3, 3s, 4, 4s, and 117. And if we do a select, well, a select star from H1, where all the values of X are greater than 0, and by the way, big hint, they're all over greater than 0. When we run explain on that, the optimizer comes back and tells us, well, I'm going to have to read 11 rows, and it's going to take, well, I know there's 11 rows, and I'm going to have to read a third of them to get the information for X is greater than 0. How many have ever played with a contractor who said, oh, I can do that in 2 days, and 2 months later you're still grinding away? This is what the optimizer said. It says, yeah, I know there's 11 rows, I'm going to have to read a third of them, and that's the way it's going to be. Well, we know that's not true. Was the optimizer lying to us? No, it's just using bad information. So, let me go to the next one. So we're going to create a histogram. You can have up to 1,024 buckets in each histogram. And we now create a histogram on the column X. And now we say explain select star from H1 where X is greater than 0 and all of them are greater than 0. It says, hey, there's 11 rows and we have to read all of them. Now, as you change this data, it gets a little bit out of date, but you don't have the overhead of an index. So we get the better estimate there. Now, indexes are fast. Histograms can be fast. Indexes require maintenance. Histograms, you can rebuild them as you need. Once again, you're not going to use it on high churning data. Occasionally, the server will do what's called an index dive to double check the statistics to make sure that the indexes are pointing to where they're supposed to be. That can hit at the wrong time. Also, indexes takes up space in disk and memory, and that's kind of an offset there. So if you have data that doesn't change very much, consider a histogram. And if you have stuff where you really need it fast and really need it super accurate, use an index. And that was a lot to cover in the time period, and I know you all have had a long day. And I'm the person who runs the Mysql track for SCaLE. So if there's anything we didn't cover this year, or anything you want to see, or you want to give your first talk and want me to help coach you through it till next March when we all are back in Pasadena, let me know. And by the way, the slides are up on slideshare.net/David M. Stokes, and you'll see it as the survey of indexes. So any questions, or are all just wiped out? Here's a guy who just walked in. He's going, hey, this is great. I got the great slide.
He was sitting here. I think wiped out is the consensus.
I was in the Postgres session yesterday, and they had 2 sessions yesterday, and that was an exhausting thing. I'm picking up Postgres now, and they do things just enough differently to kind of make me shake my head and go, oh, what's going on here? So any questions, comments, concerns? If you're shy, oh, yes, sir.
So I'm still confused about when you use serial on one of the first examples. I was thinking serial was the substitute for auto increment, and it wasn't. It screwed things up. So what was the downside of using serial? Because that created a unique.
It does a unique index. It doesn't do what you expect it to do with the auto increment. I'm talking a lot, since I switched from MySQL to Percona, I'm talking to a lot more varied audiences that don't have the MySQL background, and they're used to using the word serial. You see that in Oracle, you see that in SQL Server, you see it especially in Postgres. So.
I last used MySQL in 327, I think it was.
Oh my goodness.
It's been a while.
I think you're going to be happy with it in some cases. Yeah. Cool. Yeah. We had a question in the very back.
So you suggested bigot for the indexes as opposed to like using a unique ID. The place where I come across struggling with that is if you're a multi-master, trying to and not accidentally getting a collision. And if you're in a collision and then
Yeah, ironically, in Postgres, they have a 32-bit identifier that will actually wrap around and destroy your data. Where MySQL, basically, you run out of identifiers and the thing stops you. Now, with multi-master pointing at each other, two machines, most folks will tell you not to do that. I know folks who've run it for years without problems, but that's one of the problems, it's the collisions.
It can be done.
It can,
Specify that you have the same, specify both of the increment files so that each machine will have an offset so that the file cost is the same way. Yeah, that's how it's set up, just the same except for the reconcile and using ints.
it's just so wrought with possible errors, and it's easier to run group replication from MySQL in that sort of situation. The other thing with multi-master is a lot of people don't know how to run it or how to watch it, so you go on to the next job, next person comes in, and suddenly they've got a system that's not documented in the books, and it kind of can impinge on their career. So is there anything you want to see next year, besides Durhan's back and speaking on the MySQL track?
I didn't even respond to you this time.
Well, if that's it, thank you. Stop by the Percona booth, which has a lot of neat swag. We're right next to the MySQL booth, which also has a lot of neat swag. And with that, thank you for coming. And if you, once again, if you have suggestions for next year, or you want to try to, this is what I should do. Everyone, say once. Just comments. Okay, you've spoken once at SCaLE. Now you need to make it a second time. So.